few people that might drop in and say hello. One of which is our director of IT and software, ITSW.
Software development and IT.
SWDIT. Invisible, not just silent, but invisible.
So I love my cards up here. I'm the director of software development and IT. I oversee all of our software development that we do here and all the building's infrastructure, including our operational system. So we build our own website and ERP. They're both, you can call them open source. They're both mostly open source. They've all been built in here, either from an open source framework that we forked or our original code developed here. So those are, if you've ever bought anything for us, if you registered for this class, you did it on our website, I'm sorry. And all of our warehouse operations. So you guys went on a tour yesterday, correct? So all of the warehouse operations, everything they do runs through our ERP system. So as we receive stuff, as we purchase them from our suppliers, as they come in, we build or warehouse it, we resell it, all of that runs through our systems. That's stored off-site. We don't use cloud providers. We have bare metal down in Denver and a data center for us. So we do a lot of somewhat interesting things here. About 12 of us in the IT department here. Company of 140, about average in terms of size. It doesn't mean that we're not busy. So I'm just in there. If you guys have any questions or comments or anything else, I'd love to hear them or have a conversation with you. I'll be milling about. Most of the time is what I do. I kind of just mill about, especially, so Nate, our CEO, is here, so that I get a little bit of reprieve. So if you guys have anything you want to know or ask questions about or just trying to get some help, let me know.
So a lot of conversations. I don't know if it's not a topic of this class, but it is kind of in the ecosystem of education as an IoT conversation. Everything wants to be on the cloud, on the internet, connected devices. Tim does a lot of, he's probably one of the best people to just bend his ear and chat with about IoT and things like that. If you want to try to get devices that are connected to the web, posting data, pulling data. So, cool. Thanks, Tim. And we also have another gentleman that's been lurking around. He also is the purveyor of coffee for us this morning.
Yeah, there's new coffee.
Thank you.
Jeff, I'm the Community Development Coordinator in Education here at Sparkfun. I probably do the most travel of anybody in education, so I'm in and out a lot.
Where were you yesterday?
Yesterday I was in New York, and then I leave Thursday for Texas. So I'll be here for 2 days with you guys. I've been with the education department almost since the start. So a lot of what I do is development, partnership, and training across the country. So Brian was talking about IoT. I have a lot of large interest in the IoT topics, microcontrollers as a whole, robotics, data logging. I'm really interested in weather balloons and how we teach citizen science through data logging through weather balloons, and more recently buoys. So those are topics that you can hit me with.
How many folks are near water? We're very much not near water. Right, so Minnesota, Connecticut, Chicago, yeah. California, right? Santa Barbara, right? Yeah, so we're landlocked here. There's a few of us who have boats. So Mike has a sailboat here. It's kind of.
Go for a very short amount of time in one direction.
And then you get a turn. Circle, 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 right? Yes. Good. So I just realized that I didn't post this one onto Schoology, but I'll do that very shortly. So if you guys want to pull that up. Oh, and then I will also open up the Join Me app as well, so that when we get there, we can get that going. So take a few minutes, grab some coffee, grab some tea. Oh, I didn't realize that. We didn't put the tea out. Does anyone prefer tea over coffee? We have tea. So Jeff, can you grab? There's a box of it, right? Actually, should we leave it there?
Is it in the?
Yeah. So we have there's a hot water kettle. It's actually a coffee brewing thing, but it has a little spigot next to it that dispenses hot water. And we have Lipton tea. I think we might have some other teas, but the only tea I remember seeing there was Lipton, which is. We should, right? We should. It's like our next door neighbor. And we actually moved when we moved into this building. Before we moved into this building, we were about, I don't know, half a mile from Celestial Seasonings. We were right next door to them. So, but I didn't see any, but we'll see if we can find some for you guys. But yeah, grab some snacks. Take a few minutes to give the feedback, and then we'll get started. Today's agenda. Oh, let me, folks that want to. Oh, there it is. All right. So the join me should be up. I am gifting you guys all with some extra LEDs. This will come useful.
Thank you.
You're welcome. I'm gifting you all with extra LEDs. So, there you go.
Any rainbow LEDs in here?
Well, you can, not an individual rainbow, but you can make a rainbow.
Thank you.
Actually, the one LED that we always have problems with is there's a purple LED, and then it requires a little bit more voltage to turn on, and it's really dim. So we actually, that's not in this kit. Do you mind?
No.
Yes.
Do you also have like more of these cards?
Yeah. There should be is there a stack of them? You can. Yeah. I have a whole box of these. So if you want to take. Yeah, if you guys want to divvy up the stack, I'll bring the others. We ordered like 500 of them. So these are actually leftover. I think one of the things that, it's been branded by an event. It says Rocky Mountain Steam Fest. One of the things I learned early on was like when you print stuff, don't put the date on it, right? Certain things, like if it matters, you want to reuse it. So these are just extras. So. Yeah, five. And you can grab, and if you want to, pull off a bundle of copper wire and take it with you. And the copper tape is pretty inexpensive. It's like $4 or $5 for a roll of 50 feet, 50 yards, 50 somethings. The units matter. I don't know which unit it is though. Yes. Yeah, I'm giving people a chance to just get caught up, and then, yep.
Processing. So I downloaded it, and then I copied the Arduino part.
Yep, and you uploaded it?
And then I uploaded it,
Good.
and then on my port it's doing.
Oh, good. Okay, so you have to close this. You have to close that one first, and then run the processing. Yeah.
These can't be open at the same time.
No, and it. Let's see what's going on here. Oh, and you have two COM ports showing up. You see this is there's two COM ports. So there's a space in here where there's an index. So under this in the setup. Let me see. I'm just gonna. Oh wait. Oh wait. This is the Arduino part.
It was a rare thing. I've already had two, and they've
So
They both have had
there's a
really good
setup.
adapters. So I'm trying to figure out.
So right
how
here,
to
this is my port equals new serial, and this is the, it's saying, it's attaching to the serial list. And is your Arduino is actually,
Mine's on 4, so I should put 1 there.
Yep, yep.
This year. I'm
So
normally
then
11 or 12.
Stop.
They're anywhere from like 12 to 18.
Oh, wow.
Yeah, so I just find families.
Thank you.
Place them.
That's
I
it.
took one
So,
myself.
yep. And then what I was going to do as an activity was, can you get these 4 bars to actually move here, so that it doesn't overlap with the text. But if you move this slider,
But I like it.
Yeah.
yeah,
Thank you.
yeah, neat. So,
Brian, do you know much about iPads?
I mean, what do you?
Well, I did a video.
Oh, cool. Neat. And then you want to try uploading it to?
And there's no file system to know where this is stored.
Yeah, there's a whole Apple ecosystem that
Yeah.
you
And,
should be able to email it to yourself.
well, the problem is the video is too large for Gmail. It's like 32 meg.
Oh, and you can't upload it to YouTube?
I tried. Well, I don't have YouTube
Oh.
account. I'm not sure that I want to start.
Right, right. Well, if you have do you have a Gmail account?
Right. So I tried putting it in the cloud. I tried
Yep.
emailing it
Yeah.
to myself.
And it's too big.
And no, it said it did it, but I never got the email, so I assumed.
I never got it either. Yeah.
So that's where it's like, okay, I know it's on here, but I can't even find where to look at my pictures.
I don't know. There are
I mean, other
many people who might be better iOS type folks. So just give you guys a few more minutes to, if you guys didn't finish the reading, if you guys didn't get a chance to put it in a reflection. What's that?
Is there a place to put something out about this?
Yeah, it's kind of combined with it, but we'll talk more about chapter 2 together. Really more about the kindergarten learning is really. And if you haven't already, also just go through the discussions and read other people's posts. I've been seeing a lot of good conversations going on in Schoology. Yeah. Yeah. What? You should make one? You're not Brian.
As I'm so often.
What do you? I don't know what that means.
Downloaded everything.
Which part are you not seeing?
I had trouble getting the code to connect to the sandbox. I think there was like a code that I didn't put in somewhere.
So, did you try? Let's plug in the sandbox and we can take a look at that. So let's just see. So that's the port. It should be a USB serial.
Okay.
And then the board type is going to be a FIO. It's just because there's no real good reason, but that's the one. There you you.
you.
Yeah, no problem. Yeah. Oh. All right, so thank you so much for contributing to the discussion and having these conversations. These are the things that are going to help focus, right? This is the whole week about what we're doing here. Beyond just learning about electronics, that's one thing, right? Learning about the electronics is only a component, a piece of what we're doing. What we want to do is be able to weave that into a classroom experience. And things like the readings that I had you guys look at will help us with that. So does anyone want to share just one or like a couple snippets or sound bites that they pulled out of either the readings that they thought were really impactful or really resonated with them? Yeah. Yes.
I don't have I really liked it in the kindergarten article. I like that whole article. But one of my favorite things, and I just put this in the discussion board, so it's kind of reiterating it, but I love the line, creating children nothing is more important than learning things creatively. Like I think so often it's easy to just say, oh, I'm not a creative person and move on. But it really is a learned art. It's just like math or science. The more you're put in that situation and forced to do it, the more you can learn. There are people who are prone to math, prone to creativity, and prone to science, but it doesn't mean you can't learn it. That's not their focus.
That's awesome. Thank you.
What really hit me in the face was the section where we were talking about what's difficult for the group was saying what's harder, riding a bike, learning to ride a bike, learning programming, or learning to share. And it took me back to sharing the crayons. I was like, oh, it's the same with sharing ideas. It's just like I never made the connection between sharing thoughts and sharing things. And that's totally I don't know why I never made that connection before, but it's so difficult for us when we're little, and now it's still difficult for us now. So.
That's neat. Yeah.
I have a lot of students that sometimes think collaborating or remixing a project in Scratch is cheating. So I try to encourage them to share what they've learned with each other and say, no, it's not cheating, it's sharing your ideas and collaborating. So we've been working on that. But it's interesting because when we were kids, if you gave what you learned to somebody else, then you were accused of cheating, right?
I think there's a subtle difference. This is something that I'd love to maybe hear some of your opinions on. And there is this: if you take someone's work and you claim it to be your own,
right,
and you don't modify it or you don't integrate it into an idea of something that you're working on, that's closer to what I would consider cheating. But what we oftentimes see with students is when they build projects like this and this, the motivation to cheat, you cheat because they're trying to game the system, right? This is not something I really want to do. I got to get it done, so I'm going to here. But if they see value, right, I'm going to create something. It's right. There's meaning to it. But I don't know. Do you guys see that same kind of problem with? Is it cheating? Is it copying? Is it remixing? Yeah.
I don't have an answer to that question, but that comment led me to another question, which is, I honestly don't know in this open source environment how you give proper attribution to code. So and how do you teach your students to do that? Because I don't know how to do it.
Yeah.
And so I don't know if we're going to talk about that or.
Jeff, do you have?
None of us write, or very, very rarely do we write code from scratch. We pull in chunks of other people's code and we mix it up. Because we don't have to. I don't have to build my house from the ground up. I just have to clean it, right? But the attribution usually that I use in specific answer to your question is if I pull a big chunk of code and more than, let's say 30 or 40% of that is intact from the original author, I attribute this, I say based on code by Tom Igoe. And I pass that on. And we have, if you look at the code examples, particularly in Arduino, there are attribution examples at the top of every chunk of code.
Okay.
So that's
Does it go in
teaching.
the comments section?
Yeah, in the comments section at the top, there should be some attribution stuff. If I pull that in and I don't change that code more than 30 or 40%, I usually attribute it to that person.
Yeah, there's not like an MLA, ALA kind of format for citing it, but at a minimum, putting the person's name and at least saying, and you know, I do a rough, like my version of, like Brian's version of ALA or whatever, right? So I put a little, I put the link of where I got it, a date, and then the person who wrote it, right? Just so that I have a reference point to go back to. But you want, yeah.
That's a little similar to the engineering design process because you don't start, you want to build a bridge. It's like, whoa, let's start with the log and see how that works. You know, you really do have to build off, no pun there, but build off of what other people have done. So, you know, if you don't change it, obviously you're going to say that's so-and-so design, but if you change it significantly, you need to have a base from which you start with. What I was going to say before is that next generation science standards encourage teachers to begin with a phenomenon. That's really the whole focus now, is to begin with an event or some observation and build an entire unit around that. And I think this all lends itself very nicely to that, where you can use any of these activities as a phenomenon that builds into learning and ties into the curriculum. So
Yeah, that's great.
It's
You shared that, I think, in one of the discussions as well. That's a great idea, this idea. And I use the word phenomenon when I taught physics. Physicists use the word phenomenon to describe things that they don't really understand. Right? It's a phenomenon. We don't understand it. But let's try to build some understanding. Let's use some observation to characterize this thing called momentum or this thing called energy, right? It's a phenomenon. We know that when I do this, the number of joules in and the number of joules out appear to be the same. I don't know why. It's a phenomenon, right? But it appears to always be the same. So, oh yeah.
Go ahead. Just going to build on that. There's like kind of a controversial statement that Gary Stager makes based off a pretty famous Seymour Papert quote about personalized learning. And that constructivism, like all learning is personal because you're the one constructing the new knowledge. But it's such a big buzzword, and all the stuff we're doing, all the edutainment companies and all this, like, oh, well, it's going to be so personal. Yeah. But I just love it. All learning is personal. You're constructing.
Yeah, that's awesome.
I latched onto the visual in the kindergarten article, and that's just, I'm a visual person.
The design process?
But yes, and the idea of it being a cycle, and it made me think of our Colorado colleagues that are working from the Extension Service. You all had a graphic that was sort of, again, that, you know, it's a continuum of learning. And then I do library instruction for the sciences at DePaul. And I have a great graphic that I try to put up, at least for the first year classes that I meet with. And again, scholarship as sort of a conversation, and that's sort of the new thing in the library instruction world, but how scientific information is, you know, created in the lab, and then it's maybe presented at conferences, it's integrated into a journal article, then we read the journal article goes into dictionaries and reference sources, and then it sort of cycles around again with the question. You know, you start with your scientific question. So the graphics really spoke to me.
Yeah.
That's article.
No, that's neat. One thing I'll point out, and then we'll move on, but these are the conversations that hopefully you'll continue to have during lunch and in breaks and things like that. And I don't know how many people, I'm one of those people that has to read a book from the beginning, even when they sign, you know, chapter 2. Did anyone read the introduction? Can I just read? I just want to read the first page to you guys because this is like, I just think it's really captivating, right? So the words written so playrooms and games, animals and plants, wood and nails must take their place side by side with books and words. That was Angelo Patri. The words written nearly a century ago by the great American educator Angelo Patri could not be truer today. For generations, children enjoyed classrooms rich in the objects of childhood, as well as opportunities to use such materials in formal and informal ways. Play and experimentation were prized as the work of childhood. Until recently, teachers studied how to create interdisciplinary projects in which the playful inclinations of children were leveraged in the construction of meaning. Elementary classrooms had centers where children would explore with deliberate materials and get lost in the flow of learning something in depth. Primary teachers were polymaths who not only taught the 3 R's, but also brought the academic subjects to life through the arts. I love that, right? Through the arts. Through the mid-1980s, learning to play the piano, make puppets out of Pop-Tart boxes, create handmade math manipulatives, and teach physical education were requirements of those qualifying to become elementary school teachers. The Piagetian idea that to understand is to invent shaped how teachers taught and how children learned. The past few decades have been a dark time in many schools. Emphasis on high-stakes standardized testing, teaching to the test, deprofessionalizing teachers, and depending on data rather than teacher expertise has created classrooms that are increasingly devoid of play, rich materials, and the time to do projects. Fortunately, there's technological and creative revolution underway that may change everything, right? Right? There's like, it's just, it's,
That pendulum to swing back.
but yeah.
I'd just like to add that that's a phenomenon, that high-stakes testing every year, that's very uniquely American. You know, I've taught in 5 countries, and even in England with national curriculum, you have your 11 plus, you have your K-stage 3s with predicted outcomes, your GCSEs and your A-levels getting stars. But nowhere is it the market-driven high-stakes testing that it is in the States.
Interesting.
So a lot of countries have avoided that kind of
Oh no! Oh no!
yeah, that's changed. But when I was there in 2003, there were only certain points that it was.
The current government have done something that's physically and logically impossible. They turned back time, gone back in time. It's going to sound depressing, but it's like teaching in the 1950s, right?
Yeah.
It's going to be disappointing.
And everybody's going to be in a cabin.
Anyway, enough of that.
Right. All right, so just a reminder, and I like to just open up the morning with our goals and objectives, and just keep these in mind, right? And we're talking about these things and how we do this in our classroom. This is, right, we could teach Introduction to Arduino for your average person that wants to just tinker, but we're all educators. We want to do this for a classroom, and so we do want to understand the basics of electricity. We're going to show you guys, we're going to play with some squishy circuits here momentarily, and just build some lesson plans and activities that we can use together. So that's, I think this is last year's slide. I messed up. It says Micro4Ed 15. Oops. So one of the requests from the feedback someone said was that just like, what is the hour by hour? What are we going to do in the day? We're a little behind schedule. I do this in the morning when I think I have the best intentions in mind, but then the conversations, and it's so good I can't stop them. So we'll play with squishy circuits. We'll spend about 45 minutes doing squishy circuits and talking about multimeters. We'll get the multimeters out, show you how to use them. I have a little handout that talks about that. I guess we kind of flipped it, and then we'll then actually have just another, we kind of already did the reflection part. So then I want to talk about, we're introduced using CodeBender, and I think that was one of the things I asked people to install or log in and create an account. If you haven't done that, we'll have time to do that. What CodeBender is, it's the cloud-based version of Arduino. So it is the Google Docs version of Arduino, basically. So a lot of schools, myself included, are now Google schools, right? We put everything on Google Docs, and everything's in the cloud. CodeBender allows you to create example code. I'll show you that, where I can create an example sketch, and we can all use that same base sketch together. I don't have to give you a thumb drive or tell you to download something. You just all go to a link, and it's like sharing a Google Doc, right? So likewise, like these presentations, I can change it on the fly, and I don't have to figure out what version you have, right? Bless you. And then we're going to use CodeBender. We're going to leverage, so the light sculptures that you guys see here, we're going to do that this morning. I'm going to give you guys the time frame is going to be 90 minutes. Once I stop talking, I'm going to give you 90 minutes. Maybe, we'll see. 90 minutes before lunch to build a light sculpture. And it's not going to be perfect, but something that has lights in it that is in some sort of enclosure that uses some of these materials. Right? You will have the rest of the week to continue working on this. It doesn't have to be perfect. I just want a light sculpture of some sort. And we'll use that to continue talking about more topics as we go into the afternoon. One of the products that's in your kit is called the SIK. It's the Sparkfun Inventors Kit. It comes with 16 projects. I have converted a lot of those projects into a teacher's guide. So there is a pacing guide that I will hand to you guys. This is going to be I'm handing you guys another book of materials. It's actually it's this. I'm not going to hand it to you right now because you will then stop listening to me and start flipping through it. But this is, right, it goes through each of the experiments one at a time and talks about what's the new vocabulary words? What are the things that I want students to learn with each of these? And so this will be a kind of a nice little thing to have as a teacher reference. And then the afternoon will probably end around more likely 4-ish, so an hour earlier, and just give you some time to just do some hacking on your projects, just thinking, going outside for a walk, and did you want to?
So I think either tonight or tomorrow night, and you guys are a democracy as long as you're not hurting yourselves or anyone else, but I'm going to take the Sparkfun van. I think we have room for like 12 or 16 people. And if you'd like to see sunset from Rocky Mountain National Park, we'll run up to Rocky Mountain National Park. So if you're here, you might as well see something other than the inside of this classroom, because Colorado has certain charms.
There's some geography here.
Yeah.
There's a few folks who went on a hike with me yesterday. It was nice. So, awesome, cool. All right, well, let's talk about squishy circuits. Jeff.
That's my bag.
Oh, that's your bag. It looks like my bag. Oh. So if folks are not familiar with squishy circuits, you can Google it. The URL is very long, but it's from St. Thomas in Minneapolis. And the woman who kind of brought this to being is Anne Marie Thomas. And she's a professor there. And it's Play-Doh. It is Play-Doh that is conductive, and she also has a recipe for Play-Doh that is insulative. You can go to their website, and there's all kinds of activities. There's, first of all, the recipes of how to make it, and then videos of how to use it, and activities to do with your classroom. And I'm going to just show you guys a video of her. She gave a TED Talk. Are we?
Will this create feedback if it's running on Join Me? Do you want us to close?
Oh, I don't know. I shouldn't. I don't think the sound comes through.
Okay.
Uh-oh, I can't.
Which one are you playing music
on? Oh, this is muted. Uh-oh. Oh, no. Oh, no. YouTube's going to cut us off. Was that short enough? All right, let's try that again. Sorry. Oops. Oh, what's going on? Huh. Is there a sound on this thing too?
Good. Brian, click on the YouTube and go to the settings. Go to the computer.
I'm trying to open this up on YouTube. Oh. Ooh. I think that was it. Ooh, here we go.
and different Play-Doh recipes. And these recipes probably look really familiar to any of you who've made homemade Play-Doh. Pretty standard ingredients you probably have in your kitchen. We had two favorite recipes, one that had these ingredients, and a second that had sugar instead of salt. And they're great, you can make great little sculptures with these. But the really cool thing about them is when you put them together. You see that really soggy Play-Doh? Well, it conducts electricity. And this is nothing new. It turns out the regular Play-Doh that you buy in the stores conducts electricity, and high school physics teachers have used that for years. But our homemade Play-Doh actually has half the resistance of commercial Play-Doh. And that sugar dough, well, it's 150 times more resistant to electric current than that salt dough. So what does that mean? Well, it means if you put them together, you suddenly have circuits. Circuits that the most creative, tiny little hands can build on their own. So I'm going to do a little demo for you. So if I take this salt dough, again, it's like the Play-Doh you probably made as kids, and I plug it in to 2 leads of a battery pack, simple battery pack. You can buy them at Radio Shack and pretty much anywhere else. We can actually then light things up. But if any of you have studied electrical engineering, we can also create a short circuit. If I push these together, the light turns off, right? The current wants to run through the Play-Doh, not through that LED. If I separate them again, I have some light. Well, now to take that sugar dough, the sugar dough doesn't want to conduct electricity. It's like a wall needed electricity. If I place that between, now all the dough is touching, but if I stick that light back in, I have light. In fact, I can even add some movement to my sculptures. If I want a spinning tail, let's grab a motor. Put some Play-Doh on it, stick it on, and we have spinning. And once you have the basics, we can make a slightly more complicated circuit. We call this our sushi circuit. It's very popular with kids. I plug in again the power to it, and now I can start talking about parallel and series circuits. I can start plugging in lots of lights. And we can start talking about things like electrical load. What happens if I put in lots of lights and then add a motor, right? It'll dim. We can even add microprocessors and have this as an input and create squishy sound music that we've done. You could do parallel and series circuits for kids using this. So this is all in your home kitchen. We've actually tried to turn it into an electrical engineering lab. We have a website, it's all there. These are the home recipes. We've got some videos, you can make them yourselves. And it's been really fun since we put them up to see where these have gone. We've had a mom in Utah who used them with our kids, to a science researcher in the UK, and curriculum developers in Hawaii. So I'd encourage you all to grab some Play-Doh, grab some salt, grab some sugar, and start playing. We don't usually think of our kitchen as an electrical engineering lab or little kids as circuit designers, but maybe we should. Have fun. Thank you.
All right, so we have some Play-Doh for you guys, some Squishy Circuits Play-Doh. And just in following with their color scheme, you don't have to. We made the conductive Play-Doh purplish color and the insulating Play-Doh white, just plain color. And the way you make it is you do it on stovetop, you heat it up, you mix it. Has anyone done this before? Right. What we learned was to use a stand mixer. So you heat part of it and then you put it in the stand mixer. You let the stand mixer with a hook, a kneading hook, just run its course through it. It makes a whole lot easier, especially do large batches like this. So.
We've also learned that you do this the last thing of the day because it tends to be a challenge.
Yeah, we're doing it in the first part of the day.
Right, but with kids.
So I want to let you guys play. Now, in order to do this, you'll need a power source. And so I'm going to give you guys a couple tips. The power source, there are some constraints that you may or may not discover as you start doing this. And these are designed to help you guys encounter some learning. So there are some constraints here that you will find and discover. Hopefully as a table will come up with some solutions. So we need batteries. That's not one of the constraints. You will have batteries.
A note, as you pull these LEDs out, if I'm long on patience, that's a positive quality. If I'm short on patience, that's a negative quality. With those LEDs, long is positive, short is negative.
There are traditional electronic parts that, beyond just LEDs, that are in your SIK. So if you want to pull up your SIK and start digging in and looking at some other things. There's a screwdriver also in the SIK if you need that to open up your battery.
I'm going to make sure that you get set batteries so when you go back to your regular.
Oh, okay, thank you.
Right, yeah, because I use resistors. But I just use resistors.
How did you get that 11 minutes? Put it in your briefcase. I've given up like 3 of them. I put it in the cord.
Don't carry it on.
Don't carry it on. That's what I learned. Don't carry it on.
Yeah, I guess that one.
Whoa. Oh. Huh. Mike, when you put it to the screen, when you go to the screen, does the aspect ratio not, is it okay? Is it better to do 4:3?
No.
Okay.
Is there anyone who didn't get batteries? Is there anyone who didn't get Play-Doh? No, we're good. Okay, great. Perfect.
Two notes that as you guys are exploring, playing around. One is you should check out the site. I think I see it on a few people's computers. The stthomas.edu/squishy circuits, and I'll post that on our Schoology site as well, just so that you have access to that. Google also will find it as well. And the other thing is, while you're playing, first of all, just play. But while you're playing, in the back of your mind, somewhere back here, I want you to be thinking about what is an activity or exploration that you might be curious about yourself, or that you might actually design into an investigation for your classroom. And now, don't share it out just yet, but I want you to tease that out at your table or with the people next to you. And you'll notice that we gave you guys enough for not enough that everyone gets their own, right? It's intentional that you guys work together and talk to each other. Oh, did you guys not get battery holders? Oh, so sorry. Jeff. There are exactly 4 battery holders in here.
Have you ever had the really sticky ones? The sugar ones get really sticky. Yep. Yeah, it does. So have you guys seen the RV? Have you noticed that there's an RV with Sparkfun wrapping on it? So we toured nationally and did about 80 tour stops in 2013 nationally, and I made dough in that RV like 3 or 4 times a week, and it was like there's just flour all over it. So how many batteries
not turning on. Try.
Well, I was thinking about the screw.
If you're long on solution, that's a good. So the long side is positive.
So, do I just inject how to use the multimeter?
Yeah, because we want to check and see if there's even
More helpful for me to walk through with you, or do you just want to Yeah. So you want to measure voltage. So there's this part, the V's, right? So and the number indicates the maximum range.
Okay.
So right. So if I want to measure big volts, right, 600 V's.
Yeah, we're going to do
right. So
20.
Yep. They're 1.5 each. So 3, right? So 2 would be too little. 20, right? Yep. Yep. And then so black always goes to common. It's called COM. And then this is the one that you almost always use, is the MV, MAV, omega. Yep. Unless you're measuring big currents, and then this moves over there. Yep. So now.
Does it matter which one I switch?
Nope. So.
There's 1.74.
Through, and that's through the resistance of the dough. So, and they're kind of lined up on top of each other. There's 2 ways of connecting things. You can either put them in parallel, or you can put them, so this is parallel and this is series, right? So I can either do this, they're stacked on top, they're like parallel, or I can put them in line, and that's in series. Well, let's look at it. Are they stacked on top? Is your black and black and your red and red connected? Or are they in a row? Right. So you're going to want to basically connect them together so that they're in a row. Yeah, you can either connect your black and your red, these 2.
Oh, I see. Okay.
So now you see, basically create a super battery, right?
Okay.
There we go.
So now I would, but if I release this, that's.
So you need to like tape it. Or
tape it together, or even you could probably just do.
Oh yeah.
I mean, this means that there's going to be some resistance in here too, but these are the fun things that you can play with. Oh yeah. Did it? The batteries, or there's no batteries in it?
No. With the batteries in it, it's not letting it out. Get it cross-checked.
I can give you the batteries that I was using. What's up with that? Try this one. These are constraints that were intended for you. One and a half was red. Right, so a little bit more yellow, blue is more there's enough resistance. To you guys. Did that kind of buzz by pretty quickly? Right? So, a couple things, right? So, there's some explorations. What are some observations that folks made at their tables?
More power.
Tell me more. What do you mean by more power?
Batteries were lame. We couldn't do anything with them until we put them on.
So, how many batteries were lame? The two kind of like you saw a glimmer, right? It kind of worked. And then what did you do to boost it? You linked them together. We have a term, it's series and parallel. Are they series, are they in a row? Or are they side by side in parallel? They're in series. And it turns out this is right. I could stand up here and lecture this, but you like, oh, when I put them in a row, it seemed to work, right? And you can plan these kinds of explorations with your students. So what else did people observe? Oh, if you push it in deeper onto the dough, is that, or just more? Oh, really? Oh, interesting. There might be, and I don't know if there's like a molecular kind of contact between the lead and the dough. That's an interesting. What else? What are some other observations folks might have made? You found that there's a bigger battery, but that bigger battery goes to a device that we're going to talk about here in a minute.
We've been using the Multimeter, and it was helpful to see how we created a sushi roll circuit after using just a really simple sandwich circuit, and the sushi roll circuit has more volume of the squishy dough, the squishy circuit.
Yep.
So what we noticed is that even though it's the same exact same power source, there's a little bit less voltage making it through.
Oh, interesting.
So what we're wondering is that a relationship to, like, is resistance increasing as the volume of material that the electricity is running through also increases?
Right. It's interesting.
And could that then decrease the amount of energy that we're measuring in each of the squishy circuits?
Yeah, that's an interesting observation. I like that. We'll come back to that. Think about that. Yes.
Different blades have different brightness.
Oh, did other people see that too? That the different colors had, what was the brightest? Which one was the easiest to turn on? Blue? I don't want to tell a student that they're wrong. No, I'm joking, but it turns out that, right, so if you were to look again, you should see that the red, right, try it again, and you'll see that the red ones do light up first, right? And it's something that you'll discover, right? You're like, well, that kind of work, or that one, wait, how come theirs is brighter and mine's not? And you try the red, and the reds, and there's all kinds of deep semiconductor stuff you can do with that. All right, I want to talk about the multimeter. So folks who are not familiar with using the multimeter, I want to at least give you guys a quick primer on how the multimeter works, and then I'll give you guys a little bit more time to play around. So if you haven't already done so, there's a 9-volt battery that goes into your multimeter. Where's my keyboard? No, you're great. No. Yeah. That. There's those. Sure, here. Here's a little multimeter. There's 2 for you. Oh, yeah, you'll need the screwdriver. Yep, yeah. So I think Carolyn's got one right there. A screwdriver at least. There you go. Yep, you're welcome. I have 1. I hope Jeff has 3. 2 and 3.
Changing the shape.
Right. I mean, it's
basically like a visual for homes.
But it turns out, here's the thing, is that their observation of more volume should show a lower resistance, but it's showing a higher resistance. This is, right, so this is what I'm saying about squishy circuits. There's too many variables, and there's places where you may draw, like it should. Why? But why is it? Yeah, so that's the one kind of caution that I've seen in practice, but no. All right, so as you guys are finishing putting the batteries in there, I'm going to talk to you guys. The handout I gave you is built off of a tutorial that's on our website. That is, it's actually our most visited tutorial on Learn, on Sparkfun's Learn site, is how to use a multimeter. And I basically took the content from that and reformatted it into a handout, so that you can now use with your class. And I added some like activities to practice with. So,
thank you.
So you're welcome. So we'll walk through. I'll just walk through it really quickly with you. This is the multimeter. It has 3 main parts: the display, the knob, and the ports. The black lead, the black one, will go into your COM. That's your common. It's also kind of equivalent to the negative terminal. But it's your common. It's the return. This one will always be here and never move. The black will always be in this middle one. The red connector, the red probe that you have, will almost always live in the right port, where it says milliamps, volts, and ohms, or omega. That's like a general purpose, generic port that will allow you to measure voltage, amps, and ohms. That's why we call it a multimeter, right? It measures all 3 things. It has a couple limitations though. If you're going to measure current, when you're measuring current, if you're measuring more than 200 milliamps, there's a fuse on this side, and you'll blow the fuse if you're on this side. So if you're not sure how big the current is going to be, you move it over here, and you start here, because there's a 10 amp fuse on this side, and then you go over here. So there's different settings, and the numbers on the dial indicate the maximum range. So if I'm going to measure the voltage that you guys are playing around with here between 2 to 4 batteries, the batteries are each 1.5 volts. So which range would I set this to? 20V, 20 volts, right? Now there's 2 volt settings too. There's this V with the straight line, and there's this V with the squiggly. Does anyone know what's the difference between the squiggly and the straight line? Yeah. Right, alternating direct current. It's just to understand the concept of what those mean. Alternating is the stuff that comes out of your wall. We almost never use that in digital electronics. Almost. I shouldn't say never, but so you're mostly going to live on this side of the scale right here. And you're probably almost always going to live right here, because it's unlikely that you're going to be dealing with 200 volt systems. And you might maybe go down to lower ranges, and you can play around with it. What you'll see, and this is a great scientific reasoning concept, as you get to lower ranges, why do you think you might want to use a lower range than necessary? Or sorry, why would I use 20 volts and not 200 volts as a setting? Any thoughts?
More precise measurements.
More precise. So this is that sig figs thing that the chemistry teachers love teaching, right? Significant digits. The number of digits that you show, that it'll show, it'll be more accurate. So the 200 volt setting gives you a range of like 1 to 200, right? It gives you all this, the whole numbers. If you go to the 20 volt setting, it'll give you 20 point, right, with decimals to it. So it's more accurate. Gives you more precisions of accuracy. So for voltage, if you want to measure voltage, we're just going to set this to 20V, and you just start testing. Voltage is what we call a potential difference. So you're always measuring across two things. The other interesting thing that you might be curious about is this thing called resistance. So what does the word resistance sound like? What do you think that does to electricity? Stop it. It is the stopping power, right? It is the stoppingness of the material. Right? We get to make, the science teachers get to make up new words, right? The stoppingness of material. So if I want to measure resistance, I can click this thing over to this side and measure resistance. And again, the ranges work the same way. And the last setting that I'll point out is the continuity setting, which I heard of someone beeping. If you turn over to here, there's a little sound icon. That tells you if something is connected. And by connected, meaning it has a low resistance, right? So if you put it to that setting and you touch the two leads together, Ruth, was that you? So when you touch it together, engineers also call it ringing out a circuit because it makes a ringing sound. Because sometimes you can't see where all the wires are going, and I want to see if two things are connected. I can touch this side and I touch this side, and I can see electrically if they're connected. It's how you test for short circuits without blowing your device. So is that kind of a nice primer on how to use this? Yeah. If you're curious, and take a few minutes and just read through this a little bit. It'll talk a little bit about what you can do with this. And I put it in order of intentionally of how I would use this in a classroom. So all right, so I'm going to give you guys a little more time to play around, another like 15 minutes to investigate and play. And how's it going? So 1 means so this is 1, and nothing it means that it's maxed out. That's saying that it's like 8 megahertz. Resistive or less resistive? Through either the LED or through your resistive dough, your insulating dough.
Okay, let's try this.
Didn't make too much of a difference. But there's something to me is there's interesting about having a number, right? So there's like a, yep, right. So and there's a lot of subtleties, right? There's actually a lot of variables that affect this, and that's the biggest one is is how well the connection this probe is in there. So just squeezing that makes a big difference. Right. So the other, yep. So there's some design of experiment. Like how do I design an experiment that is more consistent? And things that I might think to try is maybe use copper tape and just so that I've got a nice surface.
Sure.
And then there's some alligator clips in here and just clipping the alligator clips to the copper tape on top of so that you've got a nice contact between the copper tape and the squishy circuit. Yep.
You're right. This is a good place to start. But then I
Right.
feel like it's like, oh, I have to put copper tape on. Why don't I just use like this real thing?
Yeah. So what I did, it's a bigger conductor. I don't know if this is true. I think the problem is it's like a radius. It's the surface tension of the dough. So you see, like when I poke that hole, when I poke a hole in there, you see how it creates like a ring.
Yeah.
So this is a really small, tight radius. If I have something that's flatter, right, it's gonna have it's gonna have more surface contact. It's gonna have better surface contact. It's just a theory of mine. You could probably also just do this where probably try this too. You might be able to just take 2 of these. So I'm gonna take these, and then have you used alligator clips before? All right, so there's a little. Oh no, I'm sorry. There's a gluten-free. Oh no, oh, I'm sorry. Do you? Okay. We have Benadryl here too, so let me know if yeah. So. Oh, results. Why is it measuring? So now we're getting a little bit better measurement, and that's in the. So the units are the same units as the setting. So not ohms, but kilo ohms.
Oh,
okay. So it's actually not right. Yeah. So well. No, it was but.
Didn't it top out there?
Right. So it's smaller now. It's in the M's mega. These are. Right. So these are.
Okay.
Right. Yeah. Yeah. So now, curiosity I might have. So we get it to settle down at 100. And, let's see, how does that? It doesn't seem still going up. Should have gone down. It was, yeah, because it keeps going, right. And that's one of those weird things. What I did last year was I took nails. I took like big nails, like hammering nails, and I soldered a wire to it. Right. Yep. Or I took these things and I wrapped them around a nail and I stuck it in there. But I wonder if it's really the contact with the dough that's like you can kind of see that it's creating like a ring, like it's that surface tension. Going down. Did, yep. Right. Yeah, right. Yeah. And these are right. These are some of these investigations that I don't know. It will go negative if you're measuring voltage and your positive and negative are reversed. So that means you're bigger than 2 volts, right? So the 1 indicates that you've maxed out. So try that again. Go ahead. Yeah. So what are you guys seeing? Yeah, cool. Oh, right. Oh, yeah. If it's right or left. Yeah. Right. Yeah, let them. Yeah, that's awesome. Yeah, that's a great idea. Right. 1.5. Yeah, 1.5. Right.
We're going to play with the 330. And then I touch each side with one of the other.
So what number did you So 0.3, this is we're talking about levels of accuracy. It's only showing how many digits. So this is now we've got 2 digits.
Okay. Have you guys developed this up?
And I've had no problem. has received it. We're not sure. My son is.
I don't know. I don't have enough
What is it?
So what do you do as far as
These are quoted to be 5 years. So resistance, you understand? So, so I see resistance. So the stopping power. How much can it slow down your power? Visualize what that looks like.
So you just open it up to like,
Resistance is like,
how does the basically the same thing, like you just go
smaller
around
We're measuring how the
They check it out and there's space to use.
Oh wow. So you just like give it to them and let it go.
Yes.
Yeah, well, okay, so what's the so if I wanted to be not as bright, I would shade it. So it's just kind of like
Or the motor not just
right. There are reasons you want to get it. There's a it's going to make the and we have these computers that give us the number of what we actually what so there's a lot of more to this thing. There's 330 and it basically says why are you doing current that's the equation that we use. So that means that I just download this and open that file and then look at it so you can change resistance goes up. Instead of trying to type that vice versa. And this is just related to we can actually just take the numbers. So yeah, 3 volts. Yeah, the numbers should work exactly as 3 volts equals current times but the units all work on amps and all to volts. So a amp, no difference. This is why the numbers work out, right? So we don't, you don't have to do any funny It's a lot to get through, I know. So which one is good? Alright, how are folks doing? We can keep playing, I know, but I wanted to just do a quick debrief here with you folks.
It's automatic. There is no...
So I'm going to give you just a few minutes to kind of clean up your area a bit. If you'd like to keep the Play-Doh, you're more than welcome to. The stuff that's already mixed together, if you can separate, that's great. But you can take that home with you guys. The Play-Doh keeps for a while, but it is it's food grade, meaning that things that are food grade and that have been hands touched on, it will grow. It will grow mold. It will grow other things. What I do is I heard someone say it, you put it in the fridge or in the freezer even.
That's my question. Can you freeze this stuff?
I don't know. Good question.
Freezing is better. The conductive Play-Doh, what I would suggest is if you keep it for more than 3 or 4 days, re-salt it when you bring it out. Because actually the salt is the actual conductor in there. So you sprinkle salt on it.
Knead it through?
Yeah. Dump, like, for the snowball size thing you have in your hand, dump 2 tablespoons of salt in there. Mix it together really well. Go for it. A little more water sometimes as you wet it.
Yep. So what are some investigations or curiosities or things that you guys were doing at your table? We just, as you guys are cleaning up, just people want to share out the things that they were playing around with or curious about. What was that? Did you guys get it to spin? No? I think there was a group over here. Did you guys get the motor to spin? Ah, interesting. It's still, huh? Right. Interesting. Interesting. That's cool. What else? What were you guys over here exploring?
We were rolling the conductive diode longer and thinner, and we saw the resistance drop longer and thinner.
Cool. Neat. Right. So as you get longer and thinner, and people who teach AP physics, or if you ever teach physics, this idea that the longer the pipe, the longer the thing is that the electricity has to go through. Well, it's harder. It's harder to get from point A to point B, right? Right? So that's an interesting relationship. And you could have your students graph this. I was a modeling physics teacher where we emphasized this idea of taking data points, making relationships on it, and then like, when I do this, this increases. When I do this, this decreases, right? That's awesome. What else did folks explore?
We looked at what the resistance was on closer to the leads that you plugged in, and then going further away, and then going on the other side of the LED versus the resistance of the LED itself.
Ah.
So there were different numbers that we had.
Cool. Yeah.
I plugged in the resistance meter, just a lump of dough, and then let it sit, and noticed that the resistance increased.
Oh, interesting. Yeah. Do you have any ideas of why that might be?
Well, we consulted the chemist here.
Yeah.
Just the concentration of the ions.
Yeah.
Electrodes change.
Yeah, I don't know. I've watched the Play-Doh, and it looks like it relaxes. There's this, so you put the probe in, there's a surface tension that happens, and then it relaxes. And I don't know if this is true. Again, this is just right. And this is conjecture. It's a curiosity. This is that I try to bring the inner Feynman in, right? This. I think what's happening is that it's just relaxing. It's starting to pull away from the probe a little bit. I don't know if that's true. And what I did last year, I told these folks here that last year what I did is I actually soldered nails, which have a larger diameter, and I stuck those into the Play-Doh, and I found a lot more consistent results when I had a larger diameter metal thing. squishy circuits, Anne-Marie Thomas, and actually one of her former graduate students now sells a squishy circuits kit. And they have, so they're basically metal tabs that are soldered to a wire, right? So again, it's all about surface contact, right? It's this idea that the more surface contact, I think, what did we see here when we squeezed on the? Right. The resistance went down, right? So, right, so.
Something that just came to mind with the version price. If we raise that off the table and a couple of pieces of straw, do you think the resistance would change because now you don't have that table contact?
I don't know. Good question. Yes. I think these are a lot of things that there may or may not be a right answer, right? There's an observational conclusion that your students can arrive, and it's not a textbook, right? We're not saying that this is what you should see, right? This is Ohm's law. We're making observations. This is what I would say is true science.
So did anybody notice anything about the legs of the LEDs?
One short.
Oh.
Why?
Was it only one side that got? The chemist, who would give us a, right? Is that, I think that's what we're seeing, right? There's an oxidation reaction happening.
There's a cathode and an anode, and much the same as we use electricity to plate things. We're actually, if we're deflating here, using that cathode and anode and passing power across that metal.
Depending on, I think depending on how much voltage you're pushing through there. We also, so 9-volt batteries work better. And I said this somewhat intentionally, jokingly, whatever, that there were constraints, right? I gave you guys 3 volts, 3-volt batteries. The 3-volt batteries were good enough to light up maybe the red and maybe the green, right? And the yellow one a little bit. But right, you had to stack 2 of them, and you get 2 of them, you get 6 volts. 9 is obviously even better, and you can push through the resistance of the dough a little better with that. So yeah.
One of the other things that I've always been curious about, Brian and I have gone back and forth about kind of the relative effectiveness of this, is taking equal amounts of conductive and insulating Play-Doh, measuring the initial resistance of the conductive Play-Doh, thoroughly mixing them together, remeasuring them, breaking them in half, mixing equal amounts of conductive and half conductive again, so we get that mixture problem, and we can actually chart out, output from that mixing. And I believe that is stoichiometry.
Stoichiometry is more of the balancing equations, but this is just, I think it's more of a relationship of resistance, right? Resistance versus concentration. But yeah, and I think that, I think even just like what happens if I add 1 tablespoon of salt? Add another tablespoon of salt, right? There's a lot of things here that are really awesome to investigate. Anne-Marie Thomas and some of her graduate students have written papers on charting this and the techniques for measuring the resistance of Play-Doh accurately. We saw over here that it kept moving depending on how well the probes were seated in the Play-Doh, right? So, but we did, and then we actually took them all and we put them back in the stand mixer and rolled it for a while.
There seemed to be a difference between the 2 bags.
Moisture has a lot to do with it, so I suspect if you charted Play-Doh from the top and Play-Doh from the bottom, you might see different values.
We've done a lot. So our boss, the director of education, has her PhD in molecular biology. So she's got a lot of practice in lab work. She has taken this recipe and methodically made it, right? And tried to design some the homogeneity of this mixture is not the greatest. And that's, I think that's a learning, it's a point for learning, right? It's okay. It's a curiosity. I think, it's not all things are perfect.
One of the interesting parts about this is push on a range of topics here that serve from teaching simple circuits to very young kids in elementary school through to characterizing, you know, kind of the mixture in different places. There's a lot of really good database science that can be run on Plato.
Yeah. Right.
And if we're talking about spiral learning, or you know, in our curriculum, so you know, Cambridge or whatever, you can see how you can build on this. And kids in high school are going, yeah, I did this lab in third grade, now I really understand it.
Yeah, it's okay to do it again, right? It's okay to do it again as big kids, right? Right? Awesome. Cool. I'm gonna take. This is intended for us to talk a little bit more about the reflection. I think we did a lot of it on Schoology, and I want to just, in the interest of time, we're going to move forward and jump into back to Arduino. And I like to just have this slide as a reminder of those cross-cutting programming concepts that we're going to weave back in. And what we're going to do today is instead of the digital sandbox where all the things were already wired, we're actually going to build the circuits in the SIK. So I want to play for you guys a little video here, and the end product is to build a light sculpture. And this is a video that I got from Amir Aboshair, who is the director at Dos Pueblos Engineering Academy. And this is a project that he came up with a couple years ago. It's a semester-long class. These are acrylic tubes, and they have LEDs underneath them. It's controlled by an Arduino. The students start out with designing it in SolidWorks. They draw out their plans. You can see them modeling it in SolidWorks. They're coming up with a topography, a layout, what looks like how they want their objects. They design it in a polar grid because he says that all things in circles are pretty. They now practice in Arduino, and they program. They test out different sequences. You kind of did this with the digital sandbox, right? On, off, on, off. How do I get the lights to turn on all at the same time? How do I get them to cascade back and forth? And you can see the students using Arduino. This is similar to what you guys had done. And then this is where they explore the art side of it. They're looking at how does it look? How, right, when I take the LED and I put it in, what colors do I want to integrate? Maybe I'll go back and change my design. Then they wire up and they solder little leads to their LEDs so that they can plug it into their circuit. The students work together. They help each other out, right? So there's a lot of these paired soldering activities, and they clean up their circuits. And then this is actually where a lot of the magic happens to me. They have a machine shop there with 15 mills and 15 lathes. And if you ever used a mill before, here I'm going to pause it. So this mill, this young boy here, there's a wheel on the right side and a wheel in the front, and it moves the mill this way and this way. If I were a math teacher, I would call that X and Y. But when they designed their layout, how did I say they designed their layout? It was in polar. It was in circles, right? So they designed their layout in what they call R theta, so the radius and the angle. And if they had taken Algebra 2, or they probably, right, they're learning this thing where you convert between polar and rectangular, and they're like, when am I ever going to need this? Turns out these machines work on X and Y, right? And you see that, right? And they start building their project. They take the thing that they designed, and they have this like just amazing pride in what they've designed and made. And then something like this, and then they program it, right? And they spend time, and now the inspiration is come up, well, I want these to turn on at the same time, or I want these to go every other on, or I want it to go in a ring, right? And you end up creating awesome sequences like this. So when I met Amir a few years back, he showed me this. He actually brought his first demo. He came up with the idea in like early August, maybe July. And he rolled with this in September that year. Crazy, nuts, right? And it was a smashing success. And then he went to ASWE and presented this stuff and talked to me, and I was like, really, really cool. Can we do something, like I don't have a machine shop. Can we do something similar with cardboard and, you know, vellum and other things, ping pong balls and, you know, and I was like, why not? Why not? So that's kind of just a little inspiration of where I want to take today's project. And there's a little handout. I'm actually just going to walk us through this together. So if you guys can do this, we'll go ahead and take out your Arduino, your breadboard from your SIK. Can you find me a breadboard? I thought I had one out here. Oh, here, I'm good. I'm good. You don't like me? Oh, so you're saying that that's not true. Jeff. Oh, need a screwdriver. So there is a breadboard holder inside your SIK. And there's two little screws. Now there's like the way the drawings are done in the SIK so that your board matches the drawings. You're going to put the board this way. I know the text is upside down, right? Our logo is upside down. And then the breadboard, our Arduino, is going to go this way, so that the connector goes towards the logo.
Which connector?
Yep. The USB connector will go towards the logo. And this will ensure that now when I look at the drawings in the SIK guide, right, this will look the same as the drawings in the SIK guide. Yep. Yeah. So, right, the way it's right, it'll always be.
This is going that way. I put these numbers. Okay.
Yep. I did too. And actually this one was like I forget that like when you're teaching and it's your first experience seeing it, it should look the same. Hello, Jeff. Blend in. You're blending in. Did you know that your breadboard fits perfectly in the middle?
I need to continue that.
Yep. Well, so then it should be right side. It should be right side up. Yeah. It should be A through. This is upside down. So it's when you're gonna hold it, you're gonna hold it this way, right? So everything reads ABC. Yep. The only thing that's upside down is the logo. Yes. What's that? You only need 2 to anchor it. I usually put them in opposite corners. It doesn't matter. Yep. Yeah, and there's. You have to kind of push down a little bit to get it started. Or we were told that from some folks that if you pre-screw it without the. Yeah, it's neat, right? I'm gonna sneak and grab a. Oh no. So when you're done, the correct position should be like this, right? The logo is upside down, right? But everything else is right side up. Logo's upside down, and then all of the writing, everything else should be right side up. And I made so many people do this, they put it on upside down. I did this for a long time and I didn't understand why the students were getting confused. And it was because, and it's a flipping, mirroring, twisting thing in your head, right? Some people can do it really well, some people can't do it at all, right? And it's really, really hard if this is your first introduction to this. So I make sure that it matches all the drawings. I've been trying to get our folks to just flip the logo, right? That's all we had to do is flip the logo. We sell enough of these that eventually the books, we sit on no more than, I think, 2 months of inventory. That's the goal, is 2 to 3 months of inventory. So we could plan it out. It could be done. These problems can be solved. Solvable problems. Nope, but I like to just, there are letters on it. I would make sure that they're right side up. Can I see this? Yeah. So the screwdrivers all have a flat end. They're defaulted with a flat end. If you pull this out, there's this. Yes. I'm pretty sure we could also ask our manufacturer to preload them Phillips side out. What's that, Jeff?
But here's the thing. Now every time I encounter a screwdriver, and I go.
You pull on it. You want to pull on it. I pulled on enough screw. I'm like, it's not really. All right, so folks that are already ahead, go ahead and log into CodeBender. There's a little sticky back on there. Yep. Do you need power? Are you? Here. Oh. Oh. That. Oh. Is it a delay? I was like, that's a Windows. I was like, I saw that on someone else's too. I was like, but that's a Windows error. That's not. Macs don't do that. I don't know what Macs do, I think. I think you could sign up with Google. Your Google credential. Well, look at all your Google accounts.
Yeah.
Yeah, yeah. That's true. It may just be telling you.
No.
It won't let you.
Oops, and that's it.
It should prompt you to. It should prompt you to install an extension. But to Firefox.
We only support this.
Oh, it might be your
I've got the latest version.
Really?
Yeah, the IT department completely renovated. Everything's up to date. And I clicked on this, and that takes me to check for my version. And
yeah, but it's even saying that it won't work on his version of Firefox.
Which maybe they updated Firefox and CodeBender isn't up to the latest.
Or yeah, that's an interesting problem. I have direct contact with the CodeBender people, so I will let them know. Try Chrome for now, and let's. No, you don't. Do you want a hand? Do you want me to? These are supposed to be. I think we should probably also ship with 4 screws. That's the other. I think I got that one started. So there's like this, and it's really hard to describe. I think I've got this muscle memory of like how you have to kind of push down while you're turning to just get the threads to cut through. Your students should be able. Well, I don't know. I don't know how it works through the IT department. Well, so what's nice about this is if you guys are a Google school, they should be able to deploy this through their Google admin something. Right. Yeah. Yep. Yes. Yeah. So yeah, Ben, do you know? Do you think you could? Is this a process that could be automated? The installation of the extension. Yeah. I guess it depends district to district, but yeah, limited. Yeah.
Breadboard uses the same FTDI.
Yep. Oh, you're seeing the same problem? Did it prompt you to install drivers when you went through the code bender?
Not today, but I've done it previously.
So code bender will say, did you install your drivers? You can actually.
It said failed.
So if you go back to code bender.
On the Windows side?
Yep, on this side, on the Mac side, yeah. Yeah, so you can. So if you click on. That's right. Oh, that was the Windows side. So if you click on this, one of those is getting started. Hover over those icons, the one below it. Is it getting started? That one. So run through that. There'll be a prompt, and it'll basically gives you, I call it the inoculation of drivers. They figured out. Yeah. Oh, all right. I saw that. Yeah. Oh, yeah. We'll come. Oh, did it already? It kind of pushed you through. Did it not let you stop? Can you go back?
Oh yeah.
Skipped a few steps. So click download driver. It won't even let you. Weird. It won't let you. Huh. I was gonna try to see if you can force the. It might think you already have the driver. So, all right. Yeah. Got it? Yeah. Is it? Right. Yep. Yep. It should. Oh, no. The driver actually. We shouldn't need to do this. Yeah. It should. Because we've already installed it on these machines. So that was it. So we were able to, we just uploaded code to it, I think. Let's go back. Let's just watch it one more time. So there's a pull down here for comp 5. So we're gonna watch those transmit receive lights. So this, the TXRX, click on that. That's the code going to it. So. Yep.
So I have the correct word.
Yep. And then. How are folks doing with CodeBender? Is everyone working through it? When you get through it, it actually automatically just pushes code to your device. It's a pretty slick alternative to installing Arduino, depending on the school district. It also is a nice way of sharing code and sharing examples. We have been able to take a lot of our tutorials and embed in the web page itself our example code. So you're reading, do this, do this, do this. Here's your code. Do this, do this, do this. Right? I don't have to go and download that. It's all one continuous stream. So this is what the process looks like. You guys probably already saw these windows. It walks you through step by step how to get started. Oh, that was. And then if you do the pull down menu, you'll probably find that there's a Sparkfun Breadboard, right? It's very nice. They've been really, really good partners. There's also an option there for the Sparkfun Digital Sandbox, so you don't have to remember that it's an Arduino FIO or whatever, right? That's such a weird thing to store in your memory. But you can remember that it's just the Digital Sandbox. And then you can just play with the code. And if you click on this Give It a Try, play with the code, you'll see the code. It looks like this, and that's really hard to see. So, And if you look at this code, is this anything new? It's the same thing we did yesterday. And on board on the Arduino is an LED that's blinking, right? So there's a debug, we call it the debug LED, and pin 13 is the one that we generally use. You don't have to hook up any hardware, right? You know it's on board. The digital sandbox has a bunch of LEDs. This one only has one. So the one thing I like to do here now is to show you guys the easiest way to building a circuit. A circuit is a circle, right? A circuit is a circle. Actually, let me see if I can pull up the activity. And I can't see what I'm pointing at. So a circuit is a circle going from through the device, through the LED, back to ground. Ground is always our return. So if we hold the LED, do you guys remember the reminder, what Jeff was saying? Which leg is positive? Long is positive. That means the short one is negative. If you look on your board, what's right next to pin 13? On the side, what? Ground. Well, ground is negative. So I can do this. This is not to be done often, but you can just take the LED, and if I want to, which leg do I want to plug into 13? The long one. I want to put the short one into, and I can just jam this right in there. We have a lighthouse.
What do you want us to do?
Sorry. Yep. So 13 and ground. Between 13 and ground. Just right into the yep. Ooh.
My one comment about this book is the size of the text. And I know I'm going to have to readers of it.
I know. So the PDF of it is available. You can enlarge it. That's one maybe kind of okay. I am also. Yeah, we're trying to balance the because you have to put less content, right?
I mean, it makes sense.
But yeah, it is small. And so the thing that I'll hand you guys this afternoon is 40 pages, right? I'm not limited by printing costs. Well, I am, but this we're producing thousands of these, right? So we need to make sure that this thing is as efficient as possible.
It makes sense. But you said this is all.
Yep, as a PDF. Yep. Yeah. So. It sent it. Yep. You tested it. Oh, well. So it turns out that the default code that we install here is also a blink. That's what we test, right? Yeah. So now, if you run it, it doesn't change, but yeah, you'll see when you. Yep. And you'll see. You can watch the TX RX lights. These are the right next to. There's a TX and RX. That's what they call transmit and receive. That's going to be the data, the program going to your board. So you'll see that. So when you click run on Arduino, you should see those go flashing back and forth, right? So
right now, are we just playing around?
So we'll walk you guys through the next part here, but I just want to make sure everyone's blinking. So once you have it blinking, right, we can now explore all the same things. I see Glenn's got his blinking faster, right? We can now make this a heartbeat. We can do different things, but now this isn't that digital sandbox. I have an LED that I could now maybe move and put elsewhere, right? I can reroute this and put into my sculptures, but we're still not using this part, right? That's one LED. If I wanted more LEDs, I have to use this funny thing. That's called the breadboard. So I just want to make a quick check-in to make sure that everyone's ready to move on before progressing. Is anyone, you guys still? But you were able to do it with the Arduino? With the Arduino yesterday, right? With the digital sandbox.
Yeah, the sandbox was able to do it.
But is the port, Jeff, the port's not showing up? And the board file is not going to make a difference. But does it does the USB serial? All right, so then click run on Arduino. That was it? That was it. No, it doesn't matter what the board is. It may just be in the background installing the driver, but Macs are usually pretty fast. All right, let me be right back. So I'm going to hand you guys the activity that I just walked you through. This is it's the light sculpture part 1, and I didn't give this to you first because, well, we just blazed through this whole thing. But all those same kind of explorations that we did yesterday with the digital sandbox, you now have that little blinking LED. I call it the lighthouse, right? The lighthouse blinking back and forth. You can create a heartbeat. You can create Morse code, right? This is those same kind of activities. But I'll hand this, is it 3 or 4? All right, there's 4. And this is the intro, right? We're then going to take next, the second handout, we'll talk about using the breadboard. And then that'll take us right to lunch. So.
Just a quick question. Just now that we're sort of connected here, can you just do it in a nutshell, code vendor? In other words, can I find code somewhere and bring it and put it into my account so my students could use?
Yes. Yeah, good question. So in CodeBender, so at the very top, that URL, it says codebender.cc/sketch : some number, right? Some 5-digit number. You can take that URL and you can share it with anybody else in the world. One of the things, so CodeBender obviously is trying to figure out a way to make money. Anything you create on CodeBender is public, right? So don't put anything on there that has private information. Obviously, it's just code, right? But if you're writing really super secret blinking code that you don't want anyone else to know about, right? That you want to patent or whatever, they have a paid account that allows you to create what are called private repos or private files. And that's one of their business models, is trying to use that. This is basically what we just ran through, which is sticking the LED in the side.
And since I'm not familiar with it, can you search for certain types of...
Yeah, absolutely. So I'm going to hand this to you guys. Can you just pass it around? So in CodeBender, here I'll demonstrate for you guys. And this is basically what we kind of just did together. So let me open up CodeBender. I may have it. So you'll notice in CodeBender, there's a search. And I can just type in, let's see, RGB. And it shows a bunch of projects. And I'll just, RGB, I'll hit enter. And there are 2,716 projects that have the word RGB in it. I can also do this, and this is, I can type in SIK. Actually, let's just type in Sparkfun. And I create a user account called Sparkfun SIK examples. And these are all of the examples that are part of the SIK book. This is actually, I'm getting a little ahead of myself, because this is what we'll do more in the afternoon. But you can search if you know, right? If your students can search for your name, your alias in CodeBender, and they can find all of your example files. They can find, right? So I can look for Brian Huang, maybe? I don't know. Actually, I've never done this. Right? So these are all the things that I've done, or I think that's me. Or my doppelganger, right? But yeah, so what makes it really powerful is this ability to share and work on code. And I can I can update it, I can change it, I can tweak it, and you can give your students skeleton code to start from, right? This idea that they don't have to start from scratch. I don't need to type all of the things in. You can say, I want you all to manipulate, I don't know, let's look at this one here. Whoa, there's a lot here. But I want you guys to change the thing on line 27, right? And the nice thing about CodeBender is that defaults to having line numbers on the side, which is also really, really, really handy, right? So, so there's a lot of things that make it. Their tagline is that they've taken everything that's wrong with the Arduino IDE and fixed it, and they put it in here. Like with Google Docs, they can continue to update this and fix things on the fly without having you to reinstall and all of that stuff, the hassle. So.
If there's a / or is it /*, is that?
Yes. That's
so is it a different kind of comment?
It is a bounded comment. It's what we call a multi-line comment. So. See if there's an example.
Oh, gotcha. Okay.
Right. So just so that everyone else gets that too. So I don't have it on this one, but on some of the examples you'll see. I don't know. So on some of the examples you'll see a /* and a */. And so you can have. Right, these all get commented out. It's what we call a multi-line comment. That's a good observation. Right, so if I had to comment out a bunch of stuff, I don't want to go ... right? Right, it's called a multi-line comment.
Can I tell my favorite comment story?
Sure. I don't know if I know this.
We do a robotics race here every year. It's the 17th of September this year, and everybody brings their robots from all over the world, and they race them around the building. And I did this with a high school team about 7 or 8 years ago, and the day before the race, this high school senior calls me, and he goes, the robot's not working. And I said, can you be more specific? He goes, it's not working. I said, bring me the robot and bring me the code. So he drives over to my house and he unloads the robot and he gets the laptop out and he opens the laptop and he's got 5,000 lines of code and there are no comments. None. I said, go comment your code. He called me 45 minutes later and he goes, I found the problem. So he's a really laconic, soft-spoken young man. His nickname is now No Comment.
And so you'll notice that as we were teaching, as I was doing the demonstrations yesterday, I didn't comment the code as I was going, which is not good modeling. But after each line or before a line, you'll see in the examples I share with you, they do have comments in them. But when I type on the fly, sometimes we don't put them in.
Edit, so I just commented
It's a great way of doing it. It's almost like it's like a sandbox, right? It's your like you can kind of leave stuff there so you don't have to retype it. You're like, okay, I'm going to comment that out and I'm going to test this. I'm going to comment that out and test this, right? So you can. It's a good way that's a great technique to demonstrate with your students of iterating. So. Yeah. They have a, not yet. They are working on it. So I don't know where they are with that. I know that they had given me some beta release of using this collaborative tool, but they're playing with that. So I haven't seen it. It's also really hard for me to collaborate with myself. They gave the access to me, but they didn't give it to anyone else at Sparkfun. So I'm like, well, that's kind of cool, I suppose. Right. All right, so let's jump into this breadboard thing. I'm going to hand you guys the next installment to this. I hope I'm not inundating you guys with paper here. I hope this is.
We're educators. We love the handouts that we can then use for our students.
And these are the examples. You guys obviously have the electronic copies of these in Schoology as well. So under resources, yep. Mm-hmm. Yes, yep. Forever and ever and ever until Schoology goes under. There's that one there. Hey, Jeff, did you hear about Fant? You should ask Cregan about Fant.
It ignores everything else.
I understood that part.
And you have one with multiple lines, you can write something big, and you put star at the beginning of it.
I think I did start off.
And then at the end of it, you do star select. That's what it is. Okay, comment, it may be a piece of code. You said, I want to try running it without that code.
All right, so this would be where I would go to. You guys all stuck the LED in. You kind of built a circuit.
So I just put that in there.
So you guys kind of built a circuit by sticking the LED in the side, but we want to build more than just one LED, right? So to build a circuit, we're going to use this thing called a breadboard. It's really called a solderless breadboard is really the correct full name of it. And what it allows us to do is connect wires together without soldering. So soldering is this art of melting metal. You're going to melt metal so that you can join two pieces of wires together. And what I used to have my students do was I would use like telephone wire, and I would have them twist the wires together and show this is how you connect two things together. I'm going to twist them together, and but then it's all twisted, right? I was like, I can't reuse it. It's like gangly, right? So what we do is we then use this thing called a solderless breadboard. There's a whole grid of holes in this. And you'll notice that the holes are grouped in sets of If you count them, 5 holes, right? 5 holes. Groups of 5 holes. Each of those groups of 5 holes, behind that is a metal clip that looks just like this, right? There's 1, 2, 3, 4, 5 little fingers. And so you can imagine if I stick a wire here, and I stick a wire here, they're connected. Now, this thing is what's inside here. So that means that anything I stick in row 16 is connected. Now, down the middle of this thing divides 2 halves of it. It's what we call the ditch. And so there's the left 16 and the right 16. It's like a split brain. The left hand does not talk to the right hand. So this is not connected to this, right? There's separate clips. Can you imagine what these look like? Does that kind of help? And it's, if you were to take the back of that little sticky part, you could destroy your breadboard if you wanted to, and you could peel back. If you have one that's not yet glued down, you can actually peel back the corner just a little bit, and you can start to see the metal clips back there. But if you peel off too much of it, the clips will fall out, right? They're just little metal clips. But there's something transparent about just showing your students what's going on in there. Now, the rows of 5 are all connected, but you'll notice on the right side and the left side, they're not rows of 5, but they are what I would call a column. A column. And what other notation or markings do you see on the right and left-hand sides? There's a positive and a negative, and we call these power rails. It's used to bring power closer to the breadboard. So the power rail, the word rail, means that the whole thing, if I were taller, I would point up there, right? Right? This whole vertical thing is connected. This whole vertical part is connected, but they're 2 separate ones because you obviously don't want to connect your positive directly to your negative. That would be a short circuit. So you'll see that these are called power rails. The columns are the sides, and they are connected vertically. So I highlighted this just to kind of emphasize or illustrate what that means. Does that make sense? We'll do more with this, and you'll kind of see in the drawing here on the first page. The drawing on the first page here, I actually drew lines all over every single one of them, right, to show how they're connected. We also have this as a PDF, this giant poster. All right, so this giant poster, what we did is we took this to Kinko's, and we just had them print it out for us, and we had them laminate it. And then you can take dry erase markers, and you can even put things like, I want to put a resistor here, or I want to put an LED. I can actually start, right? You can have your students do this in an analog way, right, without the computer. All right, questions on this? All right, so let's go to the second page. So we went from 1 LED to now 4. We're going to leap, right? We're going to take a leap. Now, there are 2 kinds of resistors in your kit. There are 10K resistors and 330 ohm resistors. I want the LEDs to be pretty bright, so do I want a big resistance or a smaller resistance? Small. And there's an Ohm's law calculation you could have your students go through to calculate the current and all these other things. But we only give you 2 options, and it's not going to hurt it if you use the wrong option. It'll just be dim, right? So now let's just review this diagram that we have here. So I've got 4 LEDs. Do they look the same? It's like the same or similar, right? Right, so let's just look at the top one. Oh, I shouldn't pick the top one because I can't point at it. Let's look at this one. So we have this orange wire. Now the color of the wire doesn't matter. Just to be clear, electricity is colorblind. Electricity does not care what color it is. We use this color just to emphasize difference. It's going from pin 11 on the Arduino over to row number 15. Also in row 15 is the long leg of the LED. The short leg is then in 16, right? And then connected also in 16 is this funny thing. We call it a resistor. And then the resistor goes to this thing, this left side rail, which at the very top, that black wire connects it to ground. Does that make sense? I'm going to look at this. That was pin, what did I say, pin 11? This is how we do it graphically, or how we do it diagrammatically. So engineers are not really good at drawing cartoons. So this is drawn in a program called Fritzing, which is free and open. So you can draw the cartoon images for your students, and you can have your students also create the drawings of what they make in this. It was one of the programs I recommended for you guys to download and install. And if folks want to see a more formal demo, I can also do that one of these days. But you can see here, this is how I draw it. This thing would be the LED. So pin 11 is connected to the LED. The LED is then connected to the resistor. And then the resistor is connected to ground. And I try to have my students look at this, right? Make sure that you see, right, that this is a cleaner way. This is a cleaner way of drawing it. Do you guys agree? Everything's in a line, straight. This is not bad. It's clean, but it's, right, you've got a whoop, and then this, and then this, and right, there's like, and so there's two ways of depicting the circuit. So I'm going to have you guys go ahead and follow through here and get your code blinking. Get the 4 blinking, and then if you want, do you think you could figure out how to add more than 4? Presumably. So I'm going to give you guys time to play around with this, and then we'll probably do the light sculpture challenge after lunch, given. Yep. If you have a question, just raise your hand. I'll come around.
Okay, so I've done this similar stuff because we did it when you came last year. So I was like, I'll make a light sculpture that lights up with a button. What the heck?
Yep.
But my code does not work because the LED is on. And this is Sparkfun's code that I hacked. And I'm like, I think all my circuit stuff is right. That's where I almost always have an error. But I'm like, the code looks right. The circuits look right. I've triple checked them.
So button state.
I changed it to low because it didn't work when it said high.
Yep, but so where are you setting button state? Where are you reading the button state?
The slide coming down. To keep too much current from going through your bulbs, if you don't have it in there, the electricity runs too fast, and it can burn it out. It can only handle a certain amount. So, like you're saying, that's one of the ways of dimming it.
So let's see how you wired it in. It's going into pin 3. But it's default when it's not. Well, it's default to high. It will always be. So right now, let's do after the something else.
color, just like a tree. And these are random assortments. I can understand where color, the same colors there. Make sure when they're checking it's okay. Black, red, green.
No, you skip pictures. I wonder if I'm not getting enough. Sorry. I'm just talking to myself, obviously. So.
Yeah, when I've had my class it's like, okay, just make sure that you sort things out again.
If you can't have a well, yeah, even because you're ending the if ends
Without telling you what.
Yep, it's basically doing nothing. You're saying if this, do nothing. That's what that
should be next to the negative.
Yeah,
that's basically one line if statement. There's nothing.
It's hard to see. It's easier to roll your hand around.
So now flip. Now figure out.
Thank you.
Yeah, you're welcome. So one of the reasons why I gave you guys extra LEDs is that the pack of LEDs that comes with the SIK gives you, I think, 4 or 5 of one color, right? So it's you have 4 colors and it's only 5 of each color. But what if I want like 8 LEDs or all to be the same? I want to create an LED ring. Or if you guys saw up front, there's that 9 LED, the 3x3 matrix. You actually can't do that unless you have more, right, of the same color LED, or you barter with a friend. So I saw a hand up. What? Amy, was that Amy? Okay. Okay. All right. What's up?
So this is down, and I have a presentation at UT.
It's not done. It's not down yet, but it may be. Oh, right now?
We're 2 days out.
I have it. Like I have it on fly at my desk, right? So.
Yeah, I would just use if you just hard code the numbers in 13, 12, 11. You don't have to use variables. There you go.
Right, so I can get rid of that.
Right. Code 13 is already listed. So that's why your rate is already good. I think it's something in my connection to the wireless.
Sorry, yeah. I guess some push.
No, it's thanks for telling me now.
Actually, what I told them was tutorials are online, probably maybe 2 or 3.
So there's Photon, Galileo,
But I was saying that we are pushing. I said what I told Cregan was, what's our so if it goes down and you're not going to support it, what's your recommendation for I can't begin to appreciate the complexity of something is now high, not so it will do what we're looking for. You won't see any cabinets when you add yeah.
So we're using code.
I just want like a fairly linear temperature and then
You know, it's all down.
Yeah, I think my kid might get a kick out of that. Because no one can see it. They go to weather underground and like, yeah, that's our house.
I haven't talked to him about surgery. With the pink one.
Basket, Nebraska. It's north end of Nebraska.
Oh, is that all?
Do we have a mill or nowhere?
Instead of using constants, I just put the numbers straight. Because like now I have to be clever. Create an LED A, LED B, LED C, or an LED 1, LED 2, LED 3. Well, you could still do it as constants, but you would name 4 constants, but they have to be different names. LED pin 1, LED pin 2, LED pin 3, and LED pin 4. So however you want to organize it. Sometimes using the constants just it cleans up the code. So instead of seeing things like 13, it's saying LED pin 1. See the kind of way of doing that?
And you can call it pin 1.
Very. You can call whatever you want.
They have one.
Yeah, well, you're saying well, not necessarily black, but you're saying that this is different. What we call the name. So instead of LED, we call it Jerry. Does that kind of make sense? Then I can use the word Jerry around the code, and now be. Yeah, right. Yep, and you can see like people when people get tired, they start using profanity and for variables.
Oh yeah.
But yeah.
Okay, so the question I have is,
There are a lot of ways of consolidating it. I'm trying to think of what's the best way to show you this. There's a lot of different ways of consolidating. One way is to create a function. You create your own function. That would be just what we call code views. Like if you see a lot of things that are repetitive, you can just create a thing that is maybe it's so you can create a function called right?
I'm doing it.
So I've been saying, so I can write a function for this isn't one of the other tutorials. This is more of an advanced. You don't normally just show this.
So I have a 9 week, 6 week class, so I'm wondering if they're going to switch to 9 weeks next term. I don't remember that 9th grade class, I think this would all be great for.
So here, the squishy circuits, honestly, you need battery packs.
Really?
You already have.
So that mistake.
And then you can go yourself.
I mean, I have 9 volt. I do a sideboard thing to go through. So I yeah. So I have breadboard. I have tons of breadboards, and I get 9 volt batteries, and then I do. It's not a battery pack, but it has the wires. It just snaps on top. They really use that. Yeah, that I already have. So I can do it with our circuit. And I did.
So this product so I can create my own custom function. I'm going to call it join. I'm going to pass it 2 parameters, a beat number and then a time delay. Now if I want to blink whatever 13 in my code with a void loop.
9 to 12, my 9th graders is what I would think about
13,
this I would do.
And so this now does, so that's one way. This is the first way. That might help consolidate. You can go anywhere in your code. It's just so you see that this has the same kind of void blink, void loop, void setup. Right? So this is void loop and void setup are each functions in itself. This is also a function. And this is like your custom function that you can then use. Generally, we put it. I suggest students to put it. Oh, after you do the loop, put it at the very bottom. It doesn't matter where it's in the code. It just has to find it. That was the other technique I was going to suggest. But so there's a thing called an array, which is basically a list. So I can create an array, which is basically I call it LEDs. And LEDs will actually have not just 1 value, they could have 8 values in it. They're like 30. You could store 13, 12, 11, 10, 8, and then I index it. And we'll talk about that. I have one of the lessons in yesterday where I use arrays.
I made an array and then I turn on like this.
Yeah. Or
cycle through all my
Right.
But then when I run it, it's let me have
Who's the news guy that does all the little science? So he's got a circuit thing going on, and so basically if you grab a bunch of it, it lights up. Oh my God, they love that because I'll hold on to it. I'm like, here in your hand, and they'll do it.
I equals 0, I equals 3, that's the addition to doing this.
This little right there? This little flat.
Does your battery be?
These are great, right? These are kind of like people start getting motivated. Like, this gets really messy, and then you're like, yeah, it does get messy. So how do we clean this up? Right? But I like to, there's like that you want the ZPD, right? You want them to struggle. You want that like the right amount of frustration, so that they're interested. You show them why.
Turns it off.
Because if I just tell it to you, like.
It works, but I press the button.
Because they would have fun.
Last year, I'm not sure I turned it on.
Oh no, I'm sorry. It's not.
Is this the right one?
Oh, that's not the right one. I don't think. But that may be part of it. What is this? Oh yeah, this is. I think this is 12 volts. I think these are 19.
So this one's one. It's going to the ground.
This is actually the other nice thing about CodeBender is that it's on the cloud. Hopefully you won't lose too much.
Does it work on Chromebooks?
It does work on Chromebooks.
And you can plug this into a Chromebook?
Yep. I have one in the office if you want to play around with it. No, it's really slick. Jeff has taught entire workshops all on Chromebooks.
It's her fault.
I'm not seeing
Why? So let's take a look. So this is what you uploaded. So this isn't going to work. Maybe it did. Interesting. So there's two things that are missing. One, so after each function, you see how setup. You see that there's a curly bracket.
Yeah.
Close curly bracket. Or loop. There's not one. I'm surprised it didn't.
Yeah, because I verified the code.
I'm surprised it didn't. I know that's why. Yeah, it didn't get an error. So let's just move this stuff. So Control X. So now we. So now that code looks okay.
Yes, my friend.
Maybe because you didn't put any delay between the high and the low. So it might.
Try it again.
Yeah, you turn it on.
Let's try this. So a couple things I like. Is it the electric right? Right. So.
Well, something casual. That's interesting.
Yeah.
Upload was successful.
We'll see what's.
I would say, yeah, try restarting Chrome.
Looks right.
Earlier, I thought it did.
Oh, nice. The code uploaded and I was glad it happened. Apparently it did.
I think I know what's going on. I saw this before too. CodeBender to create a new file. This adding a file is actually it's adding extra files to your project. But this is actually what it's uploading. Like this is the name of the project is Arduino Uno. And you created a new file that's called 4 LEDs, 4 blinking LEDs, but this isn't actually being run. Does that kind of make sense? So I'm gonna copy this. I'm actually gonna cut it out. So I'm gonna save your sketch. So I'm gonna have you do this. Go ahead and save the sketch. And then now click on the CodeBender icon. And go to create a new sketch. erase stuff you had before.
So when it's got the globe symbol next to it, that means that's what's being run.
Yeah, and that's the name of the project. Yeah.
Okay.
So let's go ahead and run this one. So now those are working. I don't. It almost seems like you might have blown out. So and this is So there's like this. It is a little frustrating. Oh wait. That's what. So that that one was off by one.
Okay, so the important thing is to have the right sketch loaded.
Yeah, and just make sure that you don't add extra files here. We actually almost never add extra files.
Okay, so how did you just modify the code that one that's got?
Yeah, I just.
Because I wasn't sure if you were going to
Right. Sorry.
Can I put my name in?
Yes, of course. Yes.
I'm trying to set up a routine, just to simplify it.
Have you ever done any like?
But it just accelerated this one. I thought that was the word this time.
Oh, so time. I don't. Oh, yep, that's fine. You can do that there, but then when you're designing, so when you define the function, you actually have to put the type here. To integrate into time.
And lowercase int.
Yep. So you have to define it in the function definition.
Okay, but then when I use it, I use it just
so in space. And time is actually
a system error.
I would.
Except that it doesn't highlight it.
It actually is probably okay, but it might. I would try this. Yep. So that's why I use things like delay time. I have to find those. Does that help?
Yeah. All right. Good. Yeah.
Did you have a quick question?
I did. See, I was following along with that. What I just done is I added files as well. But then I was kind of following it, so now I'm
Yep, and create a new one. Yep.
Right, but now uploaded.
So this one is just one LED though. What you pasted in here is still just one LED. Hopefully, you can. So go back. Click on it. That was one you just did.
Yeah.
Or I don't know which one it is. So go back to the other one. Wait, is this? There's copy that. Yes. Does that make sense? Good.
Clearly there's something wrong with this. Okay, so and then
No, I know exactly what.
Okay, can you give me your name?
Yes. So this is so I'm gonna tell everyone. I've seen this a bunch of times.
Okay.
So intuitively, I'm gonna add a file. I'm gonna start a new file. I'm gonna click here. But this turns out what this does is it adds a file to your project.
Yes.
Not so it's not a brand new file because if I click here, project found your file. This is actually what you keep uploading. Keep uploading this.
Oh, that's because I told her to do the add file. So thanks. No,
So I'm gonna do Command A.
Yes. Copy.
So Command A, did you see what happened? Right? Command A.
It highlighted.
Every all.
Yes.
A is all.
Alright.
Command X, Command C.
C to have your shot.
Software, so you have files in fast as well. Yes. So then I'm going to go back to someone click. So when you click on the code vendor icon, that takes you back to your and then now you can create a new project.
You're following along.
Yep.
Thank you. And then I can just call it. And it should
piece to make it.
Yeah, okay.
For now, I sort of just create it. We'll rename it later.
Okay, that's fine.
Right, so I create.
And then, yeah, I
Control
give it to them, because it says, make it so only one is on the screen. And then about the, yeah, make it the LED bouncing.
No, right, so I have this comment with the Multimeter folks, and they're like, nobody needs that. I'm like, because well, the thing is, once you know, you're like, hey folks, I want to point out a couple things real quick here. And this has come up a number of times. And it will come up when you try to create a new, if you want to change a program up or you want to add a new file, modify something. So in CodeBender, where is it? Where am I here? Let's go to this window. And then let's go here. So in CodeBender, if I had, let's see, this is probably the most similar to what you guys are working with, multi-blink. If I wanted to create a new file, a lot of people click here where it says add file. Now that seems intuitive. It seems like that's probably what I would do to create a new file, right? I'm working on this project, good. Now I want to do something new. I want a new file, right? Well, this is add file, not new file. Add file will just create another file in your project. And this will still be the thing that you are uploading, right? So you're not seeing changes, If I want to create a new sketch, you have to go back to your home page, which is by clicking on the CodeBender icon. If I click on this, I can create a new sketch or a new project there. So as you start iterating and you want to create different examples, this is the way. I've actually talked to the developers. I was like, you should really add a way to create a new sketch from wherever we were, right? So yeah, do you have a?
No, I found something really cool. I don't know, this maybe everybody else knows this already, but I did control find site. I always type digital instead of digital.
Oh.
And so I done it like 19 times, and I did control find, and clicked all, and then when I just typed digital once, it replaced them all with the right thing.
Whoa.
So that makes me very happy. Yeah.
So yeah, there's a find. Is there a find and replace here?
Well, so then I just did all. I clicked all, and then then you can, if you make an edit, then it'll change them all. That's awesome.
Whoa.
That's cool. Nice. That's good. Good addition.
That's crazy. That's trippy. Jeff, you?
Yeah.
Look how many cursors there are. There's like this multiplicity thing.
But then I was like, well, I'm just going to try to change control.
So say again what you did?
So here, I'll do it with you guys. So if you do Control F and you find a term. So I'm going to look for the term Control F, and I'm going to type in digital. And you'll notice that they're all highlighted. You see that? And then I think if I click, what did I do? I clicked over here. Oh, man, nope. No, that didn't work. Oh, all. Clicked all. And then I can just say Brian. And you see it changed all of them at the same time. Obviously, this isn't going to work because there's no Brian Wright. And then another really useful tip, if you're not familiar with this, is the Control-Z or Command-Z. Right? So that's the undo. I wish I oftentimes had a Control-Z on my life. Right.
Does Control-T work in this as well?
It doesn't, because that creates a new tab. But this is the reformat code, which is like Control-Shift bracket.
How do you name your project?
I can click in this box right here and just type in the new name.
Okay, so it gave it a default right.
Yeah, so if you want to rename it, just click on the text field and it'll allow you to rename it.
So how do you do the replace?
You click all. So Control F, and then I click on this all, and then I just start typing.
Okay.
Caroline. Did it work?
Highlight all. Oh, and then I type again.
Another view into naming. The first piece of code that I get working, I call root. Like maybe I'll call it robot root. The next one, when I add a change, is robot 1. The next one is robot 2, robot 3. That way I have iterative a trail of breadcrumbs through my code from where I started to where I broke it. So I can chase that back.
There's a lot of different ways of just keeping track, right? So numbering them is a nice way, or right? There's a lot of things that work really well. Do folks want to see how to create a custom function? Is that useful? And so this has come up a few times. People are like, is there any way to shorten my code? Because I've got a lot, like I'm turning this on, turning this off, turning this on, turning this off, and it's like, right? Lots of repetition. So if I want to create we're using functions that are built into Arduino. We're using digital write, we're using delay. Those are all built-in functions. Well, what if I want to create my own function that's right? Let's call it blink. I want a function called blink, and so I want to define a new function that basically, I want to use it this way. I just want to say blink 13, 1000, and I want this thing to turn LED 13 on for 1,000 milliseconds, and then turn it off for 1,000 milliseconds, right? This is just an example of what we might want to do. And so I'm going to, in my code, I'm going to go to the very bottom of my code here, before these comments, and I'm just going to type in void blink. And let me see if I can make this bigger. Ooh. Is that big enough? So void blink. This looks like void setup and void loop, right? But I'm naming it. Right? I'm coming up with a new function, and it's called blink. But I'm going to pass it 2 numbers, right? So I have to define what those 2 things are going to be. And so in the parentheses, I'm going to pass it an integer, that's the pin, and I'm going to say another integer, which is the delay time. And then now inside my blink, I can just say, I can do what I just did normally. So to blink the pin I want, digital write, oops. And instead of using the number 13, I'm going to use this variable that's called pin. And I'm going to say hi. Do I have a typo there? Yes. Digital. How's that? Delay. And then instead of putting a number in there, I'm going to use what name? Delay time. And then digital write pin low. And then delay. That defines a function called blink. Right? So now I can take, there might be sections of my code that are 4 lines of code that I can replace with blink 13, 10, or 13, 500, right? If I want it to be on and off for half a second. And this is a technique. It's a way of, we call it code reuse, right? How do I be, right? You're seeing a lot of repetition in your code. as you guys start doing this, you might start seeing a lot of repetition. You're like, how do I clean this up a little bit? Right? I don't want to have to do on then off, or on delay, off delay, right? I'm just doing the same thing over and over again. And you could also then do this, I could create other functions that are maybe, I name it a pattern, right? So pattern 1 might be 13, 11, and 9 are on, right? So odds, maybe I'll call a function odds, and I call another function evens. Does that kind of give you guys some things to think about?
Can you save your functions from having
You can't, well, yes and no. You can, there's a technique called creating libraries that you can then import, but it's, for most of the sketches that you create are pretty small. You can just open up the other one, copy it, and then paste it in. The thing that you have to be careful with is that you can't have two functions with the same name, right? I can't create my own function called loop, right? There's only one loop. There's only one setup, right? You can't have multiple things with the same name because the computers aren't smart like that, right? They can't recognize that there are two Brians in the room or two Jeffs. Right? There can only be one Jeff.
Yeah, go to the second file.
You can put it in a second file and you do an include. You've seen that before. So you can put them in that separate file and then you do a pound include, the name of the file. No, I tend to put them at the bottom. Is what I do, but it doesn't matter.
There's some conventions with coding that we tend to follow. They're not hard and fast rules. They're just conventions. Functions at the bottom. We tend to format our code in the way Brian formatted void blank. This is a very specific education practice where we do the curly brackets on separate lines. Professional coders tend to put that first curly bracket on the line that the void blank is on. We do it this way to make it more readable in a classroom setting. If I'm monitoring through 30 students, I want one thing on one line and I can go check, check, check. It's the way my brain works.
So to kind of leverage this, this might be too much, and maybe I'm going off the deep end here with you guys. People ask this about white space and code. You can actually put all of your code on one line if you wanted to. Because when the compiler looks at this, it is looking for a special character. It's looking for the semicolon. And it's looking for the semicolon. It doesn't know that they're on separate lines. It doesn't care that they're on separate lines. But holy cow, imagine trying to read that. That doesn't mean anything to anybody. All right? So you could do this. And I was probably one of those kids early on when I learned to code. I'm like, yeah, I want to put all my code on one line. Right? Because I'm the only one that can read it. But that's not what we're trying to do, right? We're not. Oops.
Brian, after you made that function, can you show me what the code looks like here when you use it?
Yeah, of course. So I'm going to just fix that. So now inside my loop, actually, in fact, let's just take this. You guys see these 4 lines of code? I'm going to delete them. And I'm going to type in blink 4, 500. And then I'm going to take these 4 lines of code. I'm going to delete that, and I'm going to say blink 5, 500. Right.
Should it be?
It doesn't have to be, but
It's got to be in the loop.
it's got to be out. You see, it's not actually in the loop, right? So loop starts and finishes here, and then this is another function below it. You see how they're kind of blocks? Right?
So wait, your script is will only work if the on and off time of the high and the low or the delay time are the same.
The way I've written it, yep. I could say, you can also do math in here. This is something that we kind of showed. I could say maybe I want the off time to be half of the on time. So what I just did there, you saw I just typed in really quick. I put a divide by 2. Right? There's a lot of cleverness that you can start, that kind of weaves it, right? As you start teasing these out and you start understanding some of the computer science tricks, it doesn't, right? You can start tweaking these things, and I can say, or maybe I want the off time to always be 500 milliseconds longer, right? I can make it, I can add, I can divide, I can multiply. You can do all of the mathematical operators right there in there, right?
It doesn't change what you're writing up.
No. Yep. Yep. So I could, maybe I want it twice as long, so I do it times 2. And that'll change, right? This is a way of, I can make one change in one small place, and if I'm using blink, it'll cascade, right? It's instead of having to make the changes in multiple places, I make the change in one place, and it cascades through all of it. How are folks feeling? I feel like we'll spend another 10, 15 minutes, and then we're going to break officially for lunch. And the plan is I want you guys to just start thinking about how you might take this, create some sequences. Well, when we get back from lunch, I'm going to give you guys an official hour and a half to start building projects. To move the LEDs off of the breadboard, I meant to put these in your kits. The way we do that are, these are special wires. Do you want to? Yeah. Take 1, 2, 3, 4. Hopefully I have enough of these. They are male to female. If I don't have enough, we'll grab a few extras. Is there? Oh, I gave you 5. Good. One more. Is that? Are we good, Jeff? Are we short?
1 right there.
We're short 1.
It should be, yes.
Oh, so close. Yep. Oh, I like that. It's like it's crowdsourcing. Can you grab? There might be so the male to female wires are, I call them just extension wires. So you can take 2 of those wires, and where the LED used to be, you're going to plug those 2 wires in the breadboard, and then you're going to plug the LED into the 2 female ends. So here, if you grab 2 of those wires, can I borrow? So, yep, 2. Right, so these are called extension. They're just 6-inch extenders, right? Like hair extenders. And what this allows us to do, right now the LEDs are all in a line on the breadboard, and you can only do so much creativity when they're bound or constrained to the breadboard. But once I stick this into the breadboard, now I can move this. This is how we build some of these projects, right? So does that make sense? If you can't figure it out, try to work with the folks at your table. Does that make sense? And if you get the polarity mixed up, you just flip the, yeah. There you go. Can I use yours as an example? Sure. So here's an example. Ooh. Right? You can point the LED at someone. Right? But that allows us to now kind of start thinking, well, what if can I grab one of these things and cut a hole in it? Or can I grab the letter A and put I don't know, right? What can I do, right? It just really kind of opens up the possibilities of things. Yeah.
There's no reason why I can't have my wires from the other side of the breadboard.
No.
Which then I can take this further out my breadboard.
True. Yeah. There's all kinds. Yeah. we're not really going, well, so there's one, yep. So when we talk about sensors, and we may more tomorrow than today, but when we start doing sensors, if you want to change, so the reference voltage is 5 volts. And so 5, everything's 5 volts. So that's kind of the standard digital logic voltage is 5 volts. Yeah, right, so when it turns on the LED, it's actually putting 5 volts, and then you can actually do an Ohm's law, 5 volts through the LED drop, right, 1.5 volts to the LED, and then you can do the difference, right, yeah, then you can, yeah, right, so then you can divide off the, yeah, so you can figure out the current going through there. When you're doing analog read, we did that with the digital sandbox, the slider, it said 0 to 1023. So that's because 1023 is 5 volts, 0 volts, and it's really, it's a reference voltage. But what if I don't want a 0 to 5 volt range? Maybe I want a 0 to 3 volt range, or I want a 0 to, right? And so if I want to change what 1023 is, I could, there's an AREF.
Yeah, there's several.
Well, so, yeah, and so there's one that's called, actually AREF is over on the right side.
Okay.
That means analog reference. And I could say maybe I want 3.3 to be my reference voltage. So I can take 3.3 and run it over there.
And that would simply make this whole line now provide 3 instead of 5.
No. It's just for reading. It's just for your sensors. It's still always going to be putting out 5 volts. Yeah. And then these are just, that's a power line. The 5V.
Oh yeah, that's what I was.
Right. So so if I wanted to maybe run 5 volts to, maybe I have a device. Yep. Right. Yep. And then actually one of the things I put in your box is the 9-volt wall wart, 9-volt adapter. You could actually plug the 9-volt into here. There's another pin here called V-in, which is right, would be your 9 volts that's coming in here. Right, so those are, and then so you can take your V-in and a ground, that's your positive and your negative, and then you can, right, yep, and all the grounds are the same. All grounds are the same. But yeah, I think, and I'll raise this up again. Just, yep. Someone else had asked, I don't know if it was you, someone had asked in the comments, they said, can we connect to other sensors that might have been, that are not Spark, someone was asking if we could connect to sensors that aren't Sparkfun sensors, and absolutely, right? It's totally generic, right? It doesn't.
That's one thing. In terms of the Arduino, I have
Yeah.
much Arduino sets that are just basic. First down codes.
Yep.
If you want to use those on the code,
Mm-hmm.
that one of those 5 ranges.
Should be, yeah. Yeah, should be. Mm-hmm. Yeah. And if not, you can email them. Their developers are really, really good. So, yeah. It is the same as the Uno. Yep. Mm-hmm. Good. Ooh, I like it. I had, there was a teacher that I saw, they showed people the random command, and then they had students, they challenged students to create, they showed them the cheap flickering LED candle light that you can get at, right? And then they challenged the students, can you create a more realistic flicker? And so there's a command called random, and so you can basically, like, how do I create a random, basically you want to create somewhat of a random time delay, right? The on and off to create almost a flickering. There's a lot of different ways, and we're only really dealing with 4 lines of code, right? It's digital write and delay. It's actually 2 lines, 2 different commands. What's going on, Fant? Did Tim come talk to you?
It's on for a random amount.
There's no backup redundancy.
would have just been like, would have flown.
That could have been
to a crash workshop, yeah. That would have been
Oh, good. Yes, what's your
Here I am. Look what I did. Don't ask me now, but good idea.
What do folks think of the croissants?
Yummy. Delish.
I mean, I've had croissants before, but these are like really, really, really good. Yeah.
You know how, like, with the product, you can get smaller advanced separate. What are those called?
Just fiber optic.
Just fiber optic buster?
Yeah.
Actually, on Amazon.
Yeah, I found it on Amazon. You see, I have some in my office. I might bring some out.
Oh, yeah. That was. When you make an adaptation to the code, to the sketch, you want to save it, but with a new name. How do you do that? I think you asked that. Yeah, I thought you asked that.
I think this is like feel like an artist kind of role. So I deal with all this stuff.
Yeah. So
Here it says blinking and then
Okay.
here new names.
Basically, back and forth as hard as
And then click the check mark. That's what I forgot to do. Then save the sketch. Saves it up to your then make modifications. You have to save it again if you don't change the name.
Fiber optic. Have you tried it? I've never played it every time I heard
It feels almost like for fishing. Yeah.
Oh, and I wrote my husband the shitty part, so let's just go tell him that's your mouth.
I bought it as fiber optic. You sold me. Now that
Well, no, because I'm looking at it, but you see the little it's like where the extruder does a certain section.
Yeah.
And the fishing line needs to
Right. That's probably what you need for the tracks.
usually one stretch.
I bet it'll be.
Laying on the side. And so if you have saved like the other, you would have had that as a separate. Because when I kept saving it, it just kept overwriting the other ones that I already done. And then I can go back to how she
Sure.
I just started to put all the stuff, whatever that day that is, or with red style. I think that's
Trial. Same here. I'm in Mobile work at it. What's interesting is it's not actually
Should fiber optic. Good fiber optic.
strands that you're talking about. All sorts of fun stuff. That's kind of working in the same thing like it's starting to look like Christmas lights.
No, but this is our. I have a right now.
I call them one argument, that's the on and off delay. I call them two arguments. The first delay is the on delay, and the second is the off delay. All right. So you can actually find two ways
All right, folks, it is 9:30. 9:31. 12:30. 9, 12, sorry. 12:30. 12:30. Let's officially break for an hour. I think there are a few folks. How was the Chinese restaurant? Folks that went? We will start. I should have said this yesterday because I think I talked for another 10 minutes and then people showed up late because, well, I started early. So 12:30 now. We will start at 1:30. Right? I will stop talking right now, shortly. But so make sure you guys, group up and take folks to lunch. Get some sunshine. Go outside. Enjoy the weather. I think it's nice out. There's not really. Do we have a food truck today?
No, I don't think so. I'll look out and see.
I mean, there is, but it's like a 3-mile walk. Yeah, this side's good. Did it work? Yeah. Ooh, neat. Yeah. Yeah, yeah. Yep. Yeah. I mean, the way those those little, I mean, they're Oriental kind of sculpture things, right? It's not popular to call them Oriental, but it's true. That's what they were, right? They had like peacocks, and my dad sold them, amongst many things. Pearls and yeah. Yep. Yeah, yeah. Yeah, absolutely. I think it's all right. I think as long as the ends are here. I'll do something. Good, thanks. All right, yep, yeah, yep, that's, just try to keep it managed, so. Just coil this.
We could take another binder clip here to have it.
In the middle? Oh, that's a good idea too.
It's weighted down.
Yeah. Yeah, that's not a bad idea. In the middle? Yeah, I'll hold this.
You're having fun?
Yeah, I don't know if this is fun, but. Oh no, I think they crossed. There's no telling how that got tangled. I think we may have to it might be easier to just, undo once, that side. All right. I won't move. All right.
Good luck. Have fun. Do your work.
Market. I see a lot of the clamshell things from Niwot Market. It's a fantastic place. Lucky's. Oh, Lefties. Oh, the pizza. Niwot. Right? It's like an Italian. Is it? What's it called, Mike? The Italian place? What is it? No. What's it? Bistro. Something bistro. Anyway. So the official design time, building time, making time starts now. It is 1:30, so I'm going to give you guys 90 minutes. At the end of the 90 minutes, we're going to just take a look at what you have. So some folks have remarked that there's this, like, just getting it structurally sound is part of, like, just a challenge in itself. And then once you have something, then you maybe go back and do a little coding, and then maybe you add a little bit more, and you do a little coding. And you'll kind of see this. It's a spiraling thing that you'll just add a little bit here, do a little bit more, right? And then you'll see that inspiration. All of the stuff along that wall on the left side here is all free. Actually, anything in this room is a free-for-all, right? So, right? If you can come up with a way of using it in your project, maybe you want to take this marker and, like, convert the marker into something that lights up. Go ahead. There are tools. There's a drill and a vise if you want to use those. There's plenty of cardboard if you want extra cardboard boxes. There's boxes. The red Sparkfun boxes are over there as well. I'm trying to think what else. Yeah. And what I want to encourage you guys to do is just start thinking and looking at stuff in terms of them as materials, right? Not just as recycled, throwaway stuff. Things like this bottle. Like, how could I use? It's already full. It's still full of liquid. You'd have to drink it all first.
I can do that.
But then if I fill this with, like, rock salt, which I think there's rock salt here somewhere. Right? What can I do with that? Or how can I hide the LED itself, but use the LED to backlight something, right? That's this. So, what's that? It's okay. It's all right. It's all right. Keep it simple. You've got this working. This is great. This is great. No. This looks really good. What are you looking for?
Foil?
I do have foil. Yeah. Good call. How's it going? Hello. There is a power adapter. It's about this big, a white box.
I saw that white box on your photo. I did not know. I have a power adapter.
What do folks feel about music? I typed in this morning, I typed in good morning music. we're just going to do a little gallery walk. Spend about 10 minutes, 5 minutes, and just want us to walk around and take a look at what we created. And some people did work through lunch, but for the most part, this is what you all created in 90 minutes. 90 minutes, right? So for some schools, that's a class period, right? That was a class period. I ran actually 100-minute blocks, but a 90-minute block is a class period. This is very doable. If you're 45-minute blocks, 45-minute classes, I don't know how you do anything. but God bless, right?
More power to you.
But yeah, let's just take a minute and just take a few minutes, walk around and look at everything, and take some photos. You know, I think this is really awesome. And I'm gonna take some photos too.
Yeah, I have to take something now.
Programming?
I just found a place where there was like here. Let me. Do you want me to run the new one?
Well, I'd have to get a video to get it. Anyone?
This one's constantly on because it's just connected to a point. When the cycle of colors ends,
I did get it.
I started out thinking I was going to make a face,
Where did you get your
Do we need to dim the lights?
Love it.
Open up. I didn't even think to open it up.
Like the water. You know, I noticed that too. But the light doesn't, Kind of fun. Yes. So
don't think anyone.
Beautiful though. Yeah.
I stole it from my mom's store. Well, I get it was my mom.
Yeah, so you have to.
And from here.
So the array is kind of a fun thing. I always keep fumbling with it until I get it to work.
It's very cool. I like it.
The colors just change.
Oh, there it is. No, there's another.
If you really want to do it right, get some sheets of
Is there really such a big
Did they tell you about Microcontrollers? We're driving to the east We're driving to like, and there's movies.
This one is, yeah, but then the rest, I love it.
Bobby goes, so
Realism, it's like a little fun. Too kind of fun.
and I right as I thought I go, turn out to be
But I love this, it's like surrealism.
Like, it was like a
What do you think?
What's our hashtag again?
Micro4Ed 16. You usually remember once you do it the first time. At least my Twitter app.
Like a story or something.
You get a video of yours, or cool. This is fun. This is so much fun to see. I'm gonna stick around. All right, folks. So, what do you think? Is this
What's your challenge? Sorry. We're actually talking about, we just have a really good idea. Yeah,
and this is the inspiration, right? Like, this is so inspiring to see what you all created. We have DNA sequences and you know, birthday candles to, right, like lots of flowers and expressions of flowers, things with eyes, things with faces. And we can take this thing that has LEDs in it and blinks, and we can actually keep on programming, right? There's a lot more we can use, and we can teach around, well, what if I want people to, well, how do I get them to blink in different patterns? How do I get, right? There are all kinds of additional things we can use now. And it's fun, right? We're just, and there's just this awesome kind of, energy that's rolling through here. So thank you so much. This is great. We are going to, I think, so this is really nice that we have these extra tables here. If you want to keep your thing and move it off your table for the time being, we can set them out on the tables there. So this afternoon, if you want, we're going to move to other stuffs. But how are people feeling? People taking breaks, bathroom breaks? I assume that we're all taking care of ourselves as we need to, right? Can I go to the bathroom? We don't, right? So,
Are we going to be using these boards again?
you will have to use the boards for the next activity, which is, but what I would do is, right, so and this is one of the nice things about having the extension wires is that you can actually just attach, maybe if you want to, if you think about wanting to rewire this up, maybe add some little tags to the wires so you know what goes to what. Just so that you have some ideas. If you're able to, and then we can start moving. We want to just clear your desk a little bit, the table, and we're going to go to, we're going to work on just the SIK. So if you need extra parts, let us know. We can, like, you use all of your LEDs in your sculpture and you need more. We can either borrow from people here or I've got extras. But if we can let's take about 5-10 minutes to clean up our areas. And kind of transfer our project somewhere safe.
Or not.
Or not. Yeah, we'll need the inventor's board, yes. So you'll need the inventor's board and the breadboard.
Yeah. Oops, I'm sorry.
You know what?
Are we?
You want to put it in the box?
Yep. I mean, yeah, as much as we're going to read. So we're checking it, right? So once you have the idea how it goes together, it doesn't take long to learn that stuff.
I didn't realize there was that much of a difference in like,
So it does save your work because if you don't have your design, you're going to jump somewhere on the order of 40 to 50 milliamps. And you will eventually burn out.
Oh, really?
So you can do it without it. There's this logarithmic brightness to your eyes that just can't tell that it's brighter because it's from really bright to really, really, really bright. Right? Like, to you, it's just bright.
I noticed yesterday on the digital sandbox when you turned on all three of the RGB, that was super bright. I like it.
Yep. Yeah.
It was super bright.
Yeah.
I think I used that.
If you turn them all on and then you strobe it,
Yeah, I like by the end of yesterday having it fully playing.
Yeah.
Oh yeah. Maybe you should turn that off. I know, and it's not like the right way. Oh, you're paying.
Stuff like that.
Just right on that's in Breadboard too.
90 minutes.
Yeah.
Anyone who's tweeting this out to Twitter, it's really nice now. You can just search for the hashtag Micro4Ed 16. You'll see everyone's things, and it's kind of fun. Actually, I know a lot of teachers are trying to use Twitter in their classroom. If you're in a high school, you can do it. If you're under 13, no dice. So.
Like I did. You want these back?
I thought you said Ryan. I went through those confused extension wires and I started sorting them. Red lights go with lights. When I do, so we do a lot of mock-ups for a book that we're writing. We take photos of them and I want to make sure that the colors match. The color in the drawing matches the color in the photograph. It doesn't matter, but it's nice. So, continuity. Details. Megan's like amazed by your attention to detail. You guys can keep the extension wires. Yep. So the extension wires are yours to keep. This is to enable you if you want to rebuild your project when you get home or you want to do other things with it. They're pretty cheap. amazing place, right? There's something. I don't know if I would have been as creative as what you all saw here if you had to keep the LEDs on the breadboard.
Right.
Oh, yeah.
I mean, that's just, it's so limiting when they're stuck on the breadboard that you can only do so much with that. And so
Do they make separate lengths?
they do, there's a 12 and a 6 that we sell. And I'm sure you can find other lengths.
You know how many you can glue together before you start getting or whatever?
It should be pretty good. I don't
You can like a lot together.
I bet. And there's a good, right, you can do like resistance per foot, resistance, like how many ohms per, and it's probably really, really, really small, like tenths of ohms.
No place like that. Wait, so Brian, you want to take everything off the board?
What's that?
Yeah, thank you.
Yeah, we're gonna need a clean board. We're gonna need a clean board to start.
Operating on the eyeballs. On the obstruction. I don't think we can save this site though. We can save the eyeball, but we can't save this site.
Not the original person.
Right.
We have sequins, but we can't have glitter. That's our rule. This is a glitter-free zone.
Just so you know how seriously that's taken, my wife worked at the makerspace at CU. They have a makerspace in the engineering department. And there was one whole room that was glitter and glue only.
That's a bad combo.
I actually just had to take for a new student, and his mother said, my only request is that there be no glitter. I was like, okay, I can abide by it. It's like an allergy, you know?
Never really get rid of it.
No, my youngest, for the first probably 3 years of his life, had glitter in his scalp. I mean, it would not come out. I mean, I saved him, I swear.
You see somebody from work, they've got the same piece of glitter, like, it's not like the whole week. It's like, you don't have a piece of glitter.
We had a woman, and you guys probably heard stories similar to this. We had a woman, I think, in this classroom, and before we were able to tell them not to open it, had glitter. I think it was in this corner, roughly here. And immediately it was across the entire classroom.
Virus right there.
Right. And we're still, I think we've gotten most of it. That was, I think, when we first moved in. All right, how are we doing? We pretty close? I love these flowers. Flower petals.
Yeah, they turn out really cool.
I prefer to have art teachers in the science class.
Hey, but there once, really good.
table is still pretty well organized. It's actually, right? Survived the chaos of building and making. And, one of the things that you guys probably have secrets in your own room and classrooms, but these bins, having bins and ways of organizing, keeping things separated is amazing. These guys, they're called really useful boxes. And it's because, right, they all stack, they have, latches on them. They're fantastic. All right.
Can you talk a little bit about the organization of flyers?
Yep. Absolutely. There's some examples that I did when I was in the classroom for keeping these things organized. The nice thing about this kit is that this stuff is clear on the top. You can see it, right? You can see everything in there. You can do a visual inspection. Especially for the libraries. We have a few libraries that check these out at their circulation desk. And so we just have a mechanism there. They have mechanisms where they basically have a sheet that they check to make sure, at least the major stuff, and then they replace things like resistors and LEDs and such. So there's like low-cost consumables. But yeah, I'll definitely talk about that. Probably on the last day, we'll talk more about just classroom management, organization, this kind of just, like, how do I do this in my room? These kind of wire shelves are great. The thing you can't underestimate is, right, so these are the projects that we did for a class of 20, 30 people, right? If you had 5 classes, you need a way to stack these things. So these wireframe shelves are really, really, really good, especially if they're on wheels. They're almost like stacks in the libraries. Do they still have those in libraries? Right, so, but you can, but just a way to just organize, give your students almost like a locker, right? Well, cool. That was really fun. That was really, really, really awesome to see all the projects that came up. I want to point out to you guys 2 places that where you can look for more ideas like this. So the first is we actually we just created a new site. I need to change that, but learn.sparkfun.com is it's where we put all of our tutorials, our resources, our reference materials. We're respinning it on another site called sparkfuneducation.com. So if you go to this site, there's at the very top, it'll say, are you an educator? Click here, and you'll see our brand new site. There's a guy who came through here, Blake, who is one of our designers, and he's been building that site, and it's really pretty, and it's nice. And it takes a lot of the stuff that we have on our website. So Sparkfun sells over 3,000 products. And we have, I don't know how many tutorials now, there are hundreds of tutorials. And we basically have curated it down to 10 to 12 things that are primary interests of educators. We put at the very top, what is making? Why do I need this in my classroom? It's very concise, it's good to point administrators to, it's really good. You just want, this is what we do. What we also launched a couple weeks ago is what we call it Inventor Space. It is our community platform for lesson plans and engagement of classes and classrooms. So the Inventor Space, the website is invent.sparkfun.com. If you guys want to check that out. On the site, you can create activities. This activity is one that has been built up in there. And the activity is basically broken down. Step 1, do this. Step 2, do this. Step 3, do this. And each of the steps, you can build in assessments. You can have the students answer a question. So do steps, do this, do this, do this. What is an LED? Right? Do this, do this, do this. What line of code do I change in order for the LED to, blink faster? And so you can build those assessments through that. The very last step we encourage people to add is upload your work. And upload your work will be a gallery. It'll create a gallery or showcase of your projects. And then you can, as a teacher, you can sign up, and then you can enroll your class. And then you can, it's like an LMS Lite. You can assign the activities to your class, and you can do progress monitoring. How fast, how far are is each person moving along in the activities? So it's a really neat site. We just launched it about 2 weeks ago. We front-loaded it with about 11 activities, one of which was this light sculpture thing. What we did here is a little bit richer, right? Those handouts and activities gives us a little bit more to do with that. But Inventor Space has, you can see these tiles, and you can see on your page, right, the breadboard light sculpture. And then we've also taken the first 8 of the SIK projects, and we built them in there as well. So the SIK itself is an example, like example code. But we took it and we said, well, if I were to instruct someone to do this step by step, how would I do that? And we're still in the process of editing and working on some of those things, but it is live, and we encourage you all to practice using it. And later on this week, we'll actually I want you all to spend a little time to build an activity from either maybe processing and some of the stuff we did yesterday. Maybe it's something we did with the digital sandbox yesterday. Maybe it's this light sculpture. Maybe we were talking about some of those hot sheets that we did yesterday. You're like, this is great, and how would I scaffold this in steps for my students? And so these are some things I want you guys to think about. So, oh, look at that. Off by like, I don't know how long. So the SIK, this is it's a perfect transition. The Inventor Space has the first 8 projects built into it, kind of step by step by step. What I want to talk about kind of in the last part of this afternoon is at least the first 4 circuits of the SIK. So if you haven't already, at the bottom there's a trap door. It actually used to be literally a trap door because it was opaque. The whole thing was black. You didn't even know. Some people didn't know that there was a book in the box. Some people still don't know that there was a bottom latch to it, but the bottom side of your SIK box has a booklet in it. That you need as a classroom to get started with this. And we call them experiments, but they're really just examples. Right? They're, especially if you're a science teacher or science classroom, you're like, that's not an experiment. We didn't experiment, we didn't change anything, we didn't modify anything, but they're really examples, right? So the projects are circuit 1, blinking LED. I feel like we're all pros at that. And you guys flip to, I think we have page numbers on here now. If you flip through here, there's some really, really awesome illustrations. Our in-house graphics team, actually it's a guy. So Pete Holm is our graphic designer, and he's done some fantastic illustrations in here that really, right, they just pop, right? So, and there was a comment that the text is a little small, so if you guys want these pages, the PDF of this is also available on our website. So you can go to this product page, the product page for the SIK, and one of the links there is a PDF of the whole manual. So you can print out, maybe I just want students to work on experiment or circuit 1. So I can print out circuit 1. And what we've done for every circuit is that it is exactly 4 pages. 4 pages this size is a 8.5 by 11 sheet, double-sided, right? Which is what I was doing in class. I would print out certain activities. This is a way to guide your students, right? We're all going to work on this one together. And so there are projects in here. When I was in the classroom, I had my students just do these projects. Follow the instructions, do this, and then I built in just like kind of little assessment rubrics. So I said, do projects 1, 2, and 3, and then combine 1, 2, and 3 together to do something unique. So project 1 is blinking LED. Project 2 is reading a potentiometer. And the potentiometer is the same thing as a slider that you guys used on the digital sandbox. But instead of a slider, this one is a knob. It's a glue knob. And then circuit 3 is an RGB LED, right? So you guys have now experienced using all 3 of those, but we did it with the digital sandbox. So, and that's this ability to see what's going on. And then I would then, right, see what kind of projects they would come up with. Now, this is great for your average person that wants to just get started with this, and this is where I'm going to unload. It's heavy. It's not that heavy, is it? You guys said you liked handouts. This is a book.
It is a book.
So folks who have it, so one of the things that I was thinking about was as you go through the projects, I thought that maybe you just bounce around. Here's one. Oh, here's 2 more. That. Just enough. So I used to tell students that, flip through this and find one that you want to do. And they would just jump right ahead to circuit 9. And they would dive into the code, and then I would realize that, oh my gosh, you don't know how to do an array, how to do a for loop, how to do a variable, and there's like, we leap too far ahead, right? We jump this way, right? You're like, I just want to do a servo, but the servo requires that the example code. And I don't know if that's true, the servo example, but I'm just using that as a random example. But I was like, well, what if we went through this? Circuit 1, then circuit 2, then circuit 3, in order. What are the new vocabulary concepts that are presented? What are the new skills that are learned? And so this is also a Google Doc that is in Schoology. That's why all these blue things these are actually hyperlinks. So I'll just take a look at the first circuit with you guys here. So circuit 1, blink. This is the example code, and then it's a link to the code vendor example code as well. And then the learning objectives, right? Putting my teacher hat on, what is it that students should learn after they have done just a regular blink? And this is what we have spent the last kind of day about doing is basics of programming, syntax and control, void setup, void loop, right? Understanding the basics of breadboard usage, right? Where do I plug in wires so that they connect together? That's just a basic understanding that if your kids just follow this drawing and plug the LEDs directly to match the drawing, well, they maybe are learning something. They're probably learning how to follow directions more than they are learning about this breadboard. But as a teacher now, I'm like, okay, I want to make sure that I take a moment to ask the students, what if I move this wire from here down to here? What else do I have to move? And this idea of troubleshooting. How do I know? How do I know how to fix this? The control of GPIO pins, right? So that's that turning on and off. Digital write high, digital write low. And then I put the commands here, the new commands that are introduced. So pin mode, digital write, delay, and a little explanation of what that is there. This was in draft form a year ago. I spent a lot of time over the last week just getting this to a point that is ready for you all to take and start thinking about and having as a resource. This, to me, is a fantastic companion to the SIK guidebook. And then I just started breaking down all the vocabulary concepts, and we can't underestimate the fact that, or emphasize the need to be explicit. Right? I started throwing around the word circuit and LED and breadboard, and if we don't make sure that your students know what these words mean, then you might just be the talking head. So I started to just brainstorm ideas of what are the new words that they may be introduced with. So I did this with each of them. So if you take a look at one, that's pretty standard, right? There's nothing new there. Circuit number 2. Circuit number 2 is the potentiometer code. And the potentiometer is this blue knob thing, right? You turn the knob, and the resistance changes. As resistance changes, your input is going to change. And you guys saw that with the slider on the digital sandbox. What was the range of the slider? It went on one end, it was 0. What was the upper end of the slider? 1023. 1023. And that's basically, it's reading a voltage from 0 volts to 5 volts. That's how it works. It's measuring a voltage from 0 to 5 volts. And so 1023 is the same as reading 5 volts. 0 is 0, so you have a linear scale, right? Of converting volts to whatever numbers those are. And this knob will allow us, we can now use that in our code. We saw the code example there, but this walks us through that part. What I want to do together is circuit number 3. So you can use this, the teacher's guide, and you can also use the SIK drawing. The SIK drawing has, it was done in Illustrator, it's a little prettier. But this is something that you can manipulate and modify on your own. But go ahead and take a few minutes and we're going to wire up this RGB LED. And then you can go to this code vendor link when you take a look at that example code. showing you this circuit before we did light school. It just helps keep in mind, right? Like, this is red, this is green, this is blue. We actually find a lot of this. Sometimes people tell us that in the guidebook, they're like, we use these colors. I'm like, I don't have these colors in my or I ran out, it's like, it calls for 3 of this color, and I only have 2 of that color. Yeah, our tech support team answers a lot of calls. It doesn't matter which color you use. Case is that you just really flip it. Try it one way. So one will be closer.
Is the longer one in the middle?
Well, it's one in the middle.
Alright.
So it's super sweet.
So do I want it in like that, the blue's there?
For the RGB LED?
No, I want, yeah.
It's actually rotated this way.
This, the G and D would be with that black wire, right?
Yep.
Okay, so I just have to coordinate that based on how I put them.
Yeah.
Okay.
You should probably rotate that.
Yeah, rotate that because that could be confusing for somebody like me.
Right, because you have to
the
rotate.
translation visual. Yeah.
That's a good point. I actually made a point to do that in the slide there. So the RGB LED, you guys notice probably, it has 4 legs. One of the legs is longer. And that long leg is actually what polarity? What leg is that, the long leg? It's common, right? And the common goes where? You notice what does it connect to? Ground. Does anyone remember on a regular LED, on a normal LED, what was the thing that we were thinking about? The long leg is... Right. So it turns out your students are going to be like, wait a minute, mister. You said the long leg was positive. This one, the long leg is. It turns out, right, for every rule, there are exceptions. And actually, it's not even a rule or, right, it's not neither. It is just, there's a longer leg, and the longer leg has a meaning to it. Okay, so there's not, and so they shouldn't automatically assume that the long leg will always be positive.
But you can buy different LEDs that have the other one.
For all the colors.
What was that? Oh, I know, I've seen kids.
Well, you copy that and then paste it into CodeBuilder. Well, down.
And so it's a little different than other people.
No, it did come up on the, just by typing codebuilder.cc/sketch:7748.
It came up with a circuit. Hit clone and edit? Yes. It's very easy for you to say. Yeah, I pulled it up now. So I was here and then I hit clone and edit and it took me to so by doing
No, it doesn't matter, but I'm just trying to make sure that
I see, then it gives it a different number. Other than, yeah. I've not used CodeBuilder, I do it the way that I did for the other ones, to cut and paste into Arduino.
So there's nothing connected to this row. There's a column. I want this to be connected to the other.
do we ever trim the wires on the resistors so that they don't quite so big anymore? Or is it useful to have
Yeah, you can, but it depends on how often you're going to do something. And this is from another tiny breadboards. And these are jumper wires. These are you're already cut again. But you still have these wires hanging away. These are all those.
And then just to get it going, but I don't think it's.
If you're not going to hear
If you just look it up into
How are you doing?
these are other ones that are about.
Yeah, and you've got it on the handout. It's here.
Here's
it was too far pulled out of my blue.
770.
It's like the negative part of your circuit.
Oh, yeah. Okay, so now there's yellow.
But that's power. And whenever we turn these things on, they become your positive. Right? It's basically
What I've been doing is cut to bring it
it has to have So actually, this is confusing to me because it goes this and then,
Right, yeah.
I don't know why they did it that way. Like, to me, this feels a little bit.
Yeah. Okay. Let's see.
So, folks, I think I see RGBs.
Yep.
Alright, so go to the CodeBender example, and this is part of the thing is that if you have your students just download the example, or take the example and upload it to their board, and they're like, I'm done. I'm done. Right? And they're like, well, what'd you learn? I don't know. I'm done. Right? And so the thing that we want to be clear about is, well, what are they learning? And what should they be learning when they do this? So, if you go through that code, you can see that there's other functions in there. The default is playing or running this thing called main colors. There's a custom function on there that's called main colors. Let me pull that up.
You've got a fun jumbled in here. So the got your bowl in the right, one in front. Oh, so it's just a you just have to not be afraid to cram it.
It was also pointed out to me that my drawing in the SIK guide is not quite the same as what's in the SIK guide. I'm sorry. It's subtly different. Maybe not so subtle, but...
So this is the longest, so this is where you want to
This is last one.
What I don't understand is why we need this. We're talking about this section of it, but why do I need this?
just you really gotta.
I understand it's
not be afraid.
What we have around here.
Yeah, it'll.
Well, so you need an algorithm, so I can figure this out. But I can plug it into this one.
So it's easy enough to avoid it. So it's
Right.
No, we don't. Do you mind just, for some reason, I just love it. Read those down and show us where the two phones are. Yeah. I mean, now with that, I can hear that.
I'm still running my
Oh, there you go. Oh, no.
Because it just gets like when I find it, you need to pick up the different colors, so you might try.
Your long leg.
Plug them in.
Because when this one goes low is the same thing as ground. Low is the same thing as ground. So now
I know what's wrong here.
I saw it just a second ago. Oh, do I just want to do Oh, sorry.
So you had, when the others go low, low is the same thing as ground.
So you've got to be sure to be in here.
Oh, and then.
When you do, so when I do digital write, let's say, so which pin would it be? It would be this green wire. So green
And the colors are matching up.
So when I do digital
recipient has to go, has to swipe
Low
up
is
and turn on
is on ground. Zero is yeah. So you're giving it a ground.
Yeah, but not the right one.
Right.
Okay. So I can, so this just, the original question, this guy, this ground transfer.
Yes.
Okay, thanks. That's not too bad. No problem.
So, is that? Yes. Questions?
We're trying to troubleshoot why we're just getting red. Or she's just getting red.
You uploaded that code, right? Why is it so fast? It should be. Oh, did you guys change the delay time?
No.
It should be like it should be seconds.
Yeah, I did. And a statement.
But oh, did you run? Did you click run on moving? So now?
Oh, now it's cutting off. Oh, look at that. It's going different now. Maybe do. Then why is hers just red? That's interesting.
I did, I just, oh.
Yeah.
Oh, this is a different code example.
Oh.
You're looking at right. So
Oh, here.
This is the bulk.
I read it to her. They read you the wrong one. My bad.
77047.
There we go. 77047. Sorry.
That's okay.
Or
4748. Oh, 48. I'm sorry. Now I'm looking at the wrong.
Yep.
So my projector, does the arrow face the direction that the RGB company is going?
It doesn't matter. The arrow.
Right.
Does it matter which slots it goes in?
It has to be the same. So the
Same as the 3000?
Well, what do you think?
Okay, so here's my 3 circuits.
Oh, yeah, and I just gave it a different, gave it its own thing.
So these 3 pins go 1, 2, and 3.
This is a different. That's the potentiometer.
Okay, so we're not hooking up against it. Okay.
That would be a later circuit. If you want to look at circuit 2, circuit 2 will show you how to do that. Yeah. All right. Is everyone getting the? So it could go red, green, blue, yellow, cyan, purple, and then is it all white?
Yes.
All white? Are you?
Oh, am I missing one? Well, I can't do this.
I was just actually the short one. Right. Short one wasn't plugged in all the way. You saw red on there, so that's working.
Okay.
Check your wires. You're lined up
Yeah. To try to figure out how the for loop
So, is everyone seeing the main colors?
Okay.
We're getting main colors? No. So, if I wanted to see the show spectrum, how would I do that? Comment it. So, if you done, let's go ahead and do it. Try it. And what do you see it doing?
Wait, could you say that again? I'm sorry. Yeah.
Oh, so you said comment out main colors. Comment out main colors in the code. So line 30. So line 30, we're going to comment that. And we're going to comment it by just putting 2 forward slashes in front of it. So line 30. And actually, can you guys edit this? You may not be able to.
Do you have to copy it in here?
Clone and edit.
There's 2 things. You can clone and edit, or you can actually just click here, edit. And it says that if I want to temporarily edit the sketch, right, I'm not going to save it to my code vendor. I'm just going to edit it. This will allow me to do it right here in the window. I can comment this one out. Oops. And then if I want to see show spectrum, I uncomment it out. And it says it's going to gradually fade from red to green to blue back to red. So go ahead and see what happens. So it's like, ooh, neat, right? But again, that's right. What did we learn to do there? What skill did we just learn how to do? We learned how to comment and uncomment code. Have we learned anything about the coding?
No.
No. So let's take a moment and let's look at show spectrum.
Oh, now it's the
Actually, before I do that, I misstepped. Misstepped. We should first look at main colors so that we understand what it's doing. I just want to look at what main colors is doing. So main colors, it starts off, it makes sure that all of the red, green, and blue are off. Then it turns red, right? So it just turns red on, then leaves green and blue off. Then it turns green on, leaves red and blue off. To create yellow, I turn both red and green on. Right. This is basic. Is this the same code that you guys were messing around with your light sculptures? But now we're actually able to create some really cool color mixing, right? And then purple, we can do that, right? So now let's talk about show spectrum. Now show spectrum actually has a couple things going on in here. So show spectrum has this funny thing called a for loop. So how many folks have seen a for loop before? So folks, there's a lot of folks here probably who have not. I'm going to look at the guide I gave you guys, this one right here. So let's look at the teacher guide. And on page 9, there's some information here about what this thing called a for loop is. So it says a for loop is a way to repeat a block of code a specific number of times using an index counter. I'll say it again, it's right here, but for loop, page 9?
It's page 10 on it.
Oh, is it? Oh, sorry. Oh, yeah. I inserted the, I did the, sorry, so the for loop is a way to repeat a block of code a certain number of times, and it uses an index counter. And the way it's broken out is there's 3 parts to it. There's what we call the initializer, there is the condition, and then there's an increment or decrement. And so now I'm going to look at line 105 here. So line 105 in my code, the first part, initializer. Initialize integer x equals 0. The second part is the condition. The condition is x is going to be less than or equal to 766. And then the last part, this is shorthand. This is a shorthand way, x plus plus. Any guesses what that shorthand means? X plus plus. X plus 1, right? That's a shorthand of writing x is equal to x plus 1. Turns out we do that so often when we're coding, they're like, we should just come up with a shorthand for it, right? So x plus plus. What do you think it would be if I wanted to do x equals x minus 1? X minus minus. Right, so increment or decrement. So then, right, so that means that x, the first time it goes through, x is equal to 0. And then I'll do this, and then I'll come back and I'll do it again, and x will now be equal to 1. I'll do it again, x will be equal to, and I'll go 3, 4, it'll go all the way until x is equal to
766.
It'll do 766, it'll be okay. It'll do one more time until it's 767, and then I'll say, is the condition true?
No.
And then I'll say, okay, I'm done. Right, so if I want to do something a specific number of times, the for loop, it's called a for loop. So it does that 767 times, turns out, because 0 and 766. But then it says, all right, so it says RGB X. But I've never heard of an RGB function. Did we ever talk about an RGB function? So do you see anywhere else where it defines or talks about RGB? You see anywhere in the code where it says RGB? Oh, right. Huh? What's this?
Right, yeah.
What's the asterisk?
What are all these asterisks? What do all these asterisks mean? Do you guys remember? No, this is just a comment. This is one giant comment block. And so here's RGB, and this talks about what it does. Basically, it breaks down the range into 767 counts. So what's 255 plus 255 plus 255?
White.
765. Or sorry, 256 plus 256 plus 256 would give you 767. 768. Ah, right. So, and basically what we're doing is we're just coming up with a way of just cascading from red to green to blue. And I'm going to look at the code here. We see there's an if statement, right? So the if statement is creating my red, some variables, red intensity, green intensity, blue intensity, and it's allowing us to go through these ranges. And the last part here is these three commands. And what's new about this command? What's new about this command that we haven't seen before? Analog write. So analog write. So before we were just turning them on and off, right? Digital write. Now it's about analog write. What was the analogy that someone said that the difference between the analog and the digital? Digital was either 0 or 1. Oh, anti-binary? Is that non-binary? Right, so it's continuous. And it turns out the number that we send with analog write is a number from 0 to 255. So now if I actually wanted to create any rainbow, any color in the rainbow, I could use 3 analog write commands. So let's let's do this really quick. So this just gives us an understanding of how to read the code. I'm going to go back, and this is really short, so I'm going to comment this out also. And I'm just going to create my own color. And you guys remember in processing how we were able to pick 3 colors, the red, the green, and blue values? Well, that was on the computer screen. I can do the exact same thing now with code, right? I can do this exactly the same thing with my RGB LED. And I can now set the 3 colors, the 3 variations, the 3 intensities of the red, green, blue. So if we had this with our light sculptures, could we have done more variations?
Yeah.
And you can create all kinds of soft colors, and you can go to colorpickers.com and look at, right, what are some other color combinations I want to play with. And I can now create an activity I would have the students do is create a disco party. Right? So pick your 3 or 4 favorite colors and turn them on and off. So what would, if I wanted to turn it off, what would I set the value to for all 3 of those pins? 0. If I wanted white light, pure white, what would I set those 3 values to? 255.
So,
question? Yeah. No. I don't know what color that's going to show. I made up those numbers.
It's going to be a yellowy, bright, whitey yellow.
I don't know.
so does that mean
Oh,
that
I
the green
tried
is
it.
off?
You got it?
Yeah, but but now I just changed it to
here.
white.
Oh,
Well, I haven't run it yet, but these are the colors that you set there.
Oh, yeah. So the question is, can I show this?
Yeah.
So these are the numbers that I just pulled out of thin air, right? It's kind of neat, right? This is a color I haven't seen yet, right? I haven't seen this color come out of an LED. Kind of cool, right? And if you take this, you hide it behind a ping pong ball or things that you guys are playing with in the last activity, you can really create some awesome color schemes. And I should have probably gone and picked a color that I knew what was going to look like a cyan, seafoam green, right? But I wanted to end. I feel like folks are saturated.
Yes.
I want to end with this part, and there was a reading. I did post it. It is optional. I do want you guys to take a look at it, though. It's called The Triumph of Tinkering by Sherry Turkle. We'll just talk a little bit about this tomorrow, about just this idea of how does making, tinkering, and engineering, right? This is actually in the reading, the chapter 2 reading that it was in the book. Where do they fit? Where do they fit in the classroom? Where do they fit in the real world? And I also want to show you guys, this was my attempt. I didn't get a chance to finish it, but my attempt at recreating Amir's light sculpture, right? So I 3D printed the base. I created some sort of topography, and then these acrylic tubes. And this thing at the very top was my test print. So this is a 1/4 inch. This is a 1/4 inch rod. How big do you think I should make this hole? Just a tiny bit bigger. So what is a tiny bit bigger? Is it 0.3 inches? Is it 3/8 of an inch? I don't know, right? So do I want to print this whole thing with the wrong size. No, I mean, you could. So instead, I printed this thing, and you can't really, I don't know if you can tell, but there's a, right? This is 0.25. The first one was 0.25. I knew it wasn't going to work. The next one was 0.35. And the next one was, or I don't know, it was 0.30. I incremented them, right? And this thing took maybe a few minutes to print, right? It's this idea of methodical practice. And we don't need to, it would be really wasteful if I printed this whole thing out and it didn't fit. Because then you're like, oh, I just wasted 6 hours on my 3D printer. So before we conclude today, do you have any questions? I would love you guys to go back to the feedback form. The feedback form before you guys leave today, or if you prefer to do it in the morning. The feedback form, and give me just some of your feedback on how today was. So that's the time. It's a fantastic story. Do I have a slide for this? I may have forgotten to put it on. So here, let me just put this up real quick. Why is it? It doesn't look.
Can I get a show of hands to see how many people might be interested in heading up towards Estes Park for Economic National Park? 4, 5, 6. Wow, that's great.
What time will you head out?
7. 8. 8.
No, not 8. You're not leaving at 8. You're gonna try to catch the.
We're gonna try to get up there. I would recommend probably taking off by 5. And I would. I'm sorry.
What about dinner?
Well, there's Estes Park. There's Lions on the way back, which has an exceptional brewery.
Oscar Blues.
There's Oscar Blues and Lion. Yeah. So.
Are you talking about tonight or tomorrow?
I'm talking about tonight. Because tomorrow night, I think Brian has his heart set on the.
We can split up. We don't.
No, we can't. No, everybody gets to do everything.
What time would we get back?
I'm shooting for 8:30.
What time is sunset?
It's sunset is probably right now about 8:30, but you're in the mountains, so it tends to drop a little earlier.
Because it goes behind the mountain.
Yeah.
You said you need help getting the seats in?
I do, but Mike will help me, because Mike is a beast. Yes.
Did you post the video? I did. It should be. I made it public. Sorry. Oh, sorry. Hold on. Oh, I should put the QR code back up there. It means, yeah, it means the, yes.
It's like you're doing it in the morning with breakfast.
Right, this is your warm-up for tomorrow.
Yes. So I did read, I mean, I do read these at night. I read last night, I read the stuff last night, and it was just good for me to think about and see. And, you know,
So it says 5 is only 3. You tell me 5 is. 5 is. No, it keeps going down. My sister's different. 5 is really good. She doesn't want to know, so he's talking to the answer, so. 5 is really good. Why is it?
started doing all kinds of like different textures, color textures, okay?